Hi everyone. Good afternoon. Sharp noon actually. Uh, good afternoon. Yes, thanks, Dr. Chandrababu. Welcome. And we're going to start very soon. I'm just taking a couple of minutes because I can still see a lot of you trickling in, and I don't want anybody to miss the start of the session. Hi, Sanchit. And while I am waiting for everybody to join in, I'm going to share my screen. I'm going to introduce the speaker shortly, and I'm going to tell you a little about what we are covering today and tomorrow because it's a 2 day session, as most of you know. What are the two sessions going to cover today, and then what are the two sessions that are going to cover tomorrow, right? So I'm gonna just go ahead, share my screen. Let me know once it's visible. You guys should be able to see my screen now. Yes, in the chat would be yes. Awesome. Thanks, Chetan. Thanks, God, Gautam. Okay. Uh, I can still see people are joining in. So I'm just gonna get started with introduction so that once Nahid starts, by then most of you would have joined in. Okay, cool. I hope I'm audible to everybody clearly. You guys have already confirmed my screen is visible. So yes, Devrat, I'll let you know about the certificate, notes, recordings, everything in a jiffy. This, if you could confirm you can hear me properly. Yes, awesome. Okay, let's get started, guys. Welcome again to the AI Launchpad. This is the day one of the Launchpad because, as I said, most of you know it is a 2 day event. We are going to have two sessions today and two sessions tomorrow. All of them are going to be jam-packed, connected, so that it builds it. This is like the literal Launchpad you would need if you're getting started, if you're getting stuck at some doubts or something that you might have. So, without further ado, let me show you the agenda for the 2 days. So, the session one on day one, like today, day one session is going to be about foundation. So, we set the baseline right? So, we have Nahid from the US who's joined in, and she's gonna, take you through it. And I'll tell you why I can't think of a better person to take this session because I'll, in a very short while, going to show you her credentials. And in the second session today itself, we are going to move from agentic AI basics to building our first AI agent using MCP, right? So once we have done that, and some of you might have already done that, but you can maybe refresh your concepts or something you knew works, but you don't know why it works, can be answered in the session two. We are going to have another speaker for session two. Session three and four tomorrow are all going to be about orchestration, multi-agent, how multi-agent systems work, and how to take something from just like a toy demo to production level and deploy it, right? And what are the kind of technical aspects of when we are doing that? What are the technical aspects we have to keep in mind or we have to know while we are doing all of that? So that said, we are anyway going to share some free resources on our Slack and Discord communities. If you haven't joined our communities, I'm going to share the links of those communities in a while in our chat once I stop presenting. I also want to know you before I come in a little later and talk about if you want to take your upskilling journey, AI upskilling journey beyond just these 2 days, because while these 2 days are super helpful for you to understand the concepts, refresh some of the concepts, see things in live, and also get a taste of our secret sauce. And I'll talk about our secret sauce very soon. You also need to have a legitimate, substantial, sustainable impact on your career. You also need to have a structured roadmap, right? And what is that structured roadmap? I'll come in a little later. But for that, I want to know you, and for that, I'm going to launch a poll very quickly. So these are the two resources you're going to get. The audience, okay? So if you're from any of these few backgrounds that are in front of your screen, or if you're a technical professional, right? We as Interview Kickstart company, and I'm going to tell you about us, we are obsessed with technical professionals. We started about 12 years ago, and I'm going to take you through our journey. And but if you're an engineer, a product manager, TPM, an EM, a data scientist, an MLE, all of these, then the session is these 2 days are going to be super helpful for you. Quickly about us. We have been doing this for 12 years. We are not new. We started in Santa Clara in the Silicon Valley in the US, and we still continue to be there. But last about since 3 years, we have also been prevalent in India. What is our secret sauce is our 700 plus mang instructors. So our instructors are people who in their day job, day on day, are scaling AI systems in the biggest of the names like Google, Amazon, Microsoft, Netflix, you name it, and we have them, right? And those are our secret sauce. So over the weekend, because our learners are also working professionals, over the weekend you guys meet, you guys learn what is happening. You obviously, there's a structured roadmap to our programs, and you learn the latest that is happening in the industry regarding AI, and how these are also the hiring managers hiring some of you. They also tell you how to crack those interviews, right? We do not believe in a straitjacketed approach. We believe that everybody deserves separate attention. So we have 18 different customizations. What I mean by that, like if you're a backend engineer, you're a full stack engineer, you are a technical program manager, you are a data scientist, everybody is going to have a separate learning journey, right? We are going to customize the AI upskilling as well as the interview preparation for you. We obviously have had about 27,000 learners already who have joined our programs in the last all of these years, and some of the compensation successes that they have achieved are right in front of your screen. And on an average we see about 18 to 22 lakh per annum hike in the current base of whoever the learner is through our after our programs, right? So more about that later, but let's get into this. Now, this is our secret sauce that I was talking about, and I mentioned it in the previous slide too. The greatest part of this launchpad is you get to meet four of our secret sauces today. And it's a sneak peek into what they cover and how they cover the concepts in our programs, in our full-fledged programs. And of course, like because it's just 2 days, so we have concised it, and it's sort of a crash course. But we are trying to bring the best to you in a very short span. But having said that, you still get to experience how they teach. So without further ado, I know a lot of people might be also writing in the chat that let's get started. So let's get started, guys. Very happy to introduce Nahid. Thanks, Nahid, for joining us from the US. And she's the principal software engineer, tech lead, and manager at Microsoft. She's been at Microsoft, she's been at Google, Capital One, all of the biggest names. You can see it in front of you. She has over a decade of experience of doing this, right? And she's currently working on leading AI security, privacy, and responsible AI for Microsoft. And I know that a lot of you, there are a lot of talks on Reddit about responsible AI and more people trying to learn that. So she's going to take you through the concepts of agentic AI today, set the foundation so that we start building from the next session, right? Okay, I'm going to hand it over to Nahid. Nahid, welcome. Thanks for joining in. For people who were
Hello.
asking, the recording will be given. Yes, recording will be given, guys. Do not worry about that. Sit back and just enjoy the session, make the most of that. And I'm going to share a poll. Like I said, I want to know you better. So please go ahead and tell me a little about you. So over to you, Nahid. Thank you.
Yeah, absolutely. Thank you for the invite. I really appreciate it. Um, all right, let's get started. We have a fairly long agenda. So, first of all, we begin with why AI really, matters. Then we will define generative AI and large language models. Then we will talk a little bit about central limitation of language models. We will examine what is prompt engineering before making the transition from a model that responds to an agent that can help and act. So finally, we study agent architecture, models, and developer frameworks. Each topic enables the next topic. We will talk about chunking and embedding, retrieval models, and all of those concepts, and that will hopefully prepare you for the more exciting sessions, the MCP, multi-agent tomorrow, and then after that, of course, how we really build a production level agentic AI. So first of all, generative AI has moved from sort of an experimental technology into the mainstream capability. So basically, we want to highlight rapid enterprise adoption and kind of like very, fast user growth in this area. The important point is not, any single statistics around it. It is the speed at which, natural language interfaces have reduced kind of like the problems and the barriers of using advanced machine learning. So earlier AI systems usually require a specialized model. Most of the time, data scientists would only be the user of those models, but foundation models now can perform many tasks through instructions and examples, and that basically lowers the cost of trying new ideas. You may see on LinkedIn, on the internet, a lot of, $1 million startups, which someone who is not even familiar with coding has kicked off. So it's really time to learn all of these concepts and kick off your own ideas, build your own stuff. Um, so why now rather than 5 years ago? Basically, there are three developments that kind of like happen all together. One is the transformer models. They scaled very effectively. We have specialized hardware, GPUs that made training and inference practical. And also, cloud APIs made really powerful models accessible without, an internal research lab. You can just pay the premium and you can get access to model unlimitedly. Also, organizations kind of like gathered large digital knowledge base and workflows that we can use LLM systems to navigate through those knowledge base, and the result is basically a capability shift and interface shift. People can express intent in ordinary language instead of learning a task specific command system. And so that is why we are really, going through this wave of generative AI and why we think it is worth learning. There are a lot of, success patterns from industry. You can see three recurring sources of value. Uber Genie reportedly saves thousands of hours through AI-powered internal support. GitHub Copilot, I'm a personal, is my favorite tool that I use. It accelerates development tasks. It can completely revolutionize developer experience. And for example, Intuit Assist applies generative AI to bookkeeping, tax of small businesses, individuals, and they do not simply these examples do not simply put a chatbot beside an existing product. They insert AI into a high frequency workflow with very useful context. So you can think about many examples. For example, coding assistant works inside the editor and sees relevant code. And so you can think of many use cases. So also separate productivity metrics from quality metrics will make us realize how valuable these are. Saving time is useful only if accuracy, safety, and user trust remains acceptable. And this generative AI wave has shown to be very reliable, shown great evaluation results as well. And AI will also automate portions of some jobs, create new jobs, reshape many, existing roles. It can forecast, about exact numbers that we need to predict. And so the final conclusion is that a large share of workers will need to reskill, upskill, and many developers already use or plan to use AI. So one practical exercise is basically to decompose your week into tasks and rate each task on repetition, language intensity, what sort of data you have available, are you able to evaluate it, is it verifiable, and what are the consequences of any error that you may make here, right? And so high repetition verifiable tasks are often really good candidates to agentify. If the task is really ambiguous, it's like high impact decisions with very weak feedback, then probably we can hold off on that. but there are a lot of tasks that we can really agentify and use AI to benefit from. So now let's get to the real meat. Generative AI basically refers to systems that create new content, including text, images, audio, code, and structured data. So these systems are usually powered by foundation models, which are like large language models trained broad enough to support many tasks rather than only one, narrow or customized prediction. So the word basically new requires care here. A generative model does not invent in the same way a person does. We as people, we have ideas. We shouldn't assume that its output is factual or original. It learns patterns from training data and produces the most likely, the most probable output depending on the input and the context that we feed it. So there is also, contrast generative AI with predictive or discriminative AI. You can think about, for example, a fraud classifier that predicts a category or probability from known inputs. A forecasting model predicts a future value. Generative AI produces an artifact, for example, code, image, audio, and so real applications oftentimes combine both of these. So for example, a support system may classify the urgency of a conversation and then retrieve some sort of policy with search and then uses these large language models to draft a response here. So you can think about combination of traditional machine learning with these generative AI and how we can benefit from it. So, what are large language models? A large language model or LLM is literally a neural network, but it is trained on enormous collection of text and often code. Most modern LLMs use the transformer architecture. The transformer paper, if you want to read it, it is published by Google brain team in 2017, and the title of the paper is attention is all you need. So this method is particularly effective at modeling relationship among tokens in a sequence. Token may be word, may be part of a word, it may even be punctuation or any small unit of text. So each token pays attention to all tokens in that sequence, and that is the novel capability here. So during the pre-training, a very common objective is to predict the next token, and the goal is kind of like sounds simple, but be succeeding across billions of examples requires learning patterns of grammar, style, fact, code structure, reasoning, and you can even expand it to other languages which may have different grammars. So um, basically what the model is doing is that it calculates a probability distribution for what should come next, token after token. So you can even see that inference is also very expensive. So tokens matter operationally because of context limits, because of latency, because of the price. And so a long conversation or retrieved document or system instructions, need to compete for the available context window. More context is not always better. Sometimes we may have irrelevant text, and that can distract your model and it can just increase noise. So you will see a lot of keywords in this talk. For example, context engineer, prompt engineering. We are moving to graph engineering, loop engineering. Context engineering is the discipline of placing the smallest, highest quality set of instructions and evidence into a window. So yeah, that is all of the concepts that you will see in generative AI. Then we will talk about its capabilities and limitations. I mean, they can summarize, they can translate, classify, they can extract information, they can do sentiment analysis, answer questions, all of these. But fluency is not proof of truth or understanding. Models, depend on their training data. They have limited context window. They may lack recent information, there is a knowledge cutoff point in time. They may miss a key fact that is buried under its context limit. So we should design systems that provide relevant evidence, make sure that the output is correct, and use deterministic tools to calculate and evaluate these systems, right? So some limitations, call for different remedies. For example, use RAG for private or changing facts, calculate for arithmetic, code execution for, verifiable computations, a schema for any machine readable output. And then also another solution is fine tuning. It may improve, some sort of recurring behavior or domain style, but it is not a reliable substitute for a current factual database. So think about its limitations and its capabilities. We even have, a lot of solutions to fix these limitations. So now, yeah, so think about, this question. Imagine that we're building a customer support assistant, and the base model may understand general language and common support patterns. But how will it know our current return policy, product catalog, account procedures? So that knowledge may be private, and it may be frequently updated and absent from the model's training data. We can just simply, think about it and maybe post your thought process as I walk through the solution in the chat. I would want you to engage and think about possible solutions to this. So one way is like we can just paste every document into every prompt, but that would be very expensive, slow. It will exceed the model's context window. We could retrain or fine tune the model, but continuously updating model weights is usually not the simplest way, and also GPUs are expensive. So what we need is a method that finds the small amount of relevant company information for each question and gives it, to the model at answer time. So that is the problem that retrieval augmented generation is going to address for us. And there are different ways to provide knowledge. Prompt stuffing includes the source directly, and works for a small known document, and RAG searches a larger, changing collection, and is appropriate when evidence must be selected at runtime. Fine tuning, changes the model behavior through examples, is useful for stable patterns such as tone or classification style. And so we need to basically decide, do we want to do prompt, do we want to do RAG, do we want to do fine tuning? And this is a whole, knowledge base that you need to learn through architecting agentification, like system design questions. Now let's move to RAG, retrieval augmented generation. It combines two stages. First, we have a retrieval system, and it's going to search an external knowledge source for information relevant to the user's question. Then the application places the information into the model's prompt and asks the model to answer using, the supplied evidence here. So you can think of it as giving the model a targeted just-in-time reference packet. Let's say if a customer asks whether a sale item can be returned, the retriever locates the current return policy, and then the LLM turns those kind of like passages into a clear response. And a complete RAG flow often usually includes query preparation, retrieval, filtering, re-ranking, prompt construction and generation, and more importantly, citation. So we can make the LLM response factual. You can think about and you can actually observe that a lot of traditional machine learning concepts such as filtering or re-ranking or generation are all part of RAG. So it's not like we are abandoning the whole traditional ML. We are just using it differently and as a means to enable ourselves. So yeah, that is basically RAG. So what are, the benefits of RAG? RAG offers several practical benefits. It can, access recent or dynamic information without the need to retraining the model, without the need to having, GPUs. It can reduce hallucination by grounding the answers in retrieved text. It allows a smaller model to work with a large external knowledge base, and it also supports, domain adaptation by simply changing, the indexed content. It can cover legal, it can cover healthcare, it can cover military information. It can also improve trust by returning citations or links to the source passages. So RAG also, has some costs and weaknesses. It adds ingestion pipelines, search infrastructure, latency, and evaluation of RAG is a very hot topic nowadays. So retrieval can miss the answer, return contradictory information, expose content that users should not see, impose safety, security issues, and adding irrelevant context can make the model even worse. So RAG is kind of like strongest when the knowledge can be represented in kind of like retrievable sources and users' questions have some sort of evidence somewhere in the collection. So let's move to now chunking. RAG cannot simply retrieve an entire library for every question. Long documents must be divided into smaller units that can be searched and supplied to the model. And this process is called chunking. Chunking sounds mechanical, but it strongly kind of like influences the retrieval quality. If your chunks are too large, they may contain, several unrelated topic and waste context. If they are too small, they may, separate a statement from the definitions or relevant information to it. It's not going to be interpretable, right? So there are, several chunking strategies, and each of them solve a different problem. We can have, for example, fixed size chunking. It is very fast. It is predictable and useful for, an early creating an early baseline, but it can cut through sentences, right? It's fixed size. You can have sentence or paragraph-based chunking. It preserves natural language boundaries and is good for articles, policies, support documents. We can have recursive chunking. It tries, successively smaller, separators, making it a strong general purpose choice for kind of like mixed prose of the document. One of the most popular ones is called semantic chunking, which it uses an embedding or a model to detect, topic shifts. It can create more coherent chunks, but it's going to cost a lot. It's harder to tune. And so document aware, chunking respects the structures such as heading, tables, slide boundaries, functions, these things. So you can think about if we were, indexing a contract, would we rather split every 500 tokens or preserve the complete clauses and their headings? Think about the use case and then based on that, decide what sort of chunking strategy you would want to have here. So now, what is chunking really? What does it do? It breaks, long content into manageable pieces that models and retrieval system can then process it efficiently. Each chunk becomes a potential unit of retrieval, and the objective is not, to meet the token limit or anything like that. It is to preserve meaningful boundaries. So you can think about, a policy manual. It might be split by heading and paragraph, source code by class and function, support conversation by message terms, and we can also, add overlap. So think about, a practical starting guide for short, frequently asked in question entries. Keep each question and answer together, often with no overlap. If you have long narrative documents, begin with roughly a few hundred tokens per chunk and a little bit of overlap, and then tune from the evaluation. So depending on your application, decide on a method, build a baseline, evaluate, and then, go over the process again. Remember, overlap is kind of like an insurance against boundary loss. It's not, a free quality boost. If we have large overlap, we create kind of like near duplicate results. We kind of like consume the context, we increase embedding. There will be a storage cost associated with it. and the model may kind of like overemphasize those repeated claims. There are alternative techniques, for example, sentence window retrieval index a small sentence for a precise matching, but return that sentence together with all of its nearby sentences. The other one can be parent-child retrieval. You can index smaller child chunks, then provide the larger parent section to the model. And these techniques separate the unit used for matching from the unit used for answering the question. So there are a lot of details about chunking that we can definitely dig into. So now uh, sorry, from document to a vector database. So this diagram shows you the ingestion pipeline. We begin with an original document, we divide it into chunks, we transform those chunks to embeddings, which we will learn next, and store them in a vector database. From this point forward, the chunk is a basic unit of work for retrieval. In real implementation, we normally store more than chunk text and its vector. We also attach metadata such as source document, heading, page number, author, all of these, the document version. And this metadata later on allows for filtering and citation. And it also allows you to update the information easily. Later on, if you just want to update the specific part, you can find that piece of text, and then update its version, update its time, so it finds the updated version, updating the rag as easier as well. And then the ingestion pipeline should be repeatable, it should be observable. We record which parser, chunking version, embedding model, what is the source version, all of these. And then we try to preserve links from each child chunk to its parent document. And before embedding, we remove boilerplates such as repeated headers and footers. There are a lot of considerations like this basically. So yeah, that is basically the whole process. Now, we can also, the one thing that we want, I want you to also learn here is the recursive chunking flow. So the recursive, the recursive part, basically we need to segment the document into paragraphs or, theme sections, select one segment and compare its size with our chunk size limit. If the segment already fits, we keep it. If it's too large, we split it into different parts. The word recursive simply means that the same decision is applied repeatedly to smaller pieces of information. Now let's move to basically embeddings here. So once we have useful chunks, we need a way to search them by meaning rather than only by the exact word. So as a result, we convert each chunk into a numeric, vector, and that vector is called embedding. And so this is a key conceptual shift. Computers can easily compare numbers, and an embedding model basically maps text into a point in a really high dimensional space, so that it's semantically related text tends to occupy nearby regions. Embedding kind of like does not preserve the original sentence in a human readable format. It encodes the features that are learned by the model, and we use those numerical relationships to estimate which chunks are most relevant to a query. Embeddings can represent more than text. We can have multimodal models. They can even embed images, audio, combinations of content, and they allow tasks such as image to text search. And so the important requirement is that items intended for comparison occupy, some sort of a compatible representation space. So what is embedding? An embedding is a vector representation of content. A vector is simply an ordered list of numbers. It can be hundreds or it can be thousands of dimensions long. And text with, related meaning should produce vectors that are closer according to a similarity measure. It can be cosine similarity, it can be dot product. For example, how do I reset my password? And I cannot sign it because I forgot my credentials. They should share few exact words. Yet an embedding model can place them, near each other because they express related intent. Both of them are worried about password, worried about credentials. A keyword search would miss this relationship. So we embed, both, stored chunks and the user's query with the same embedding model. We compare the query vector with the stored vectors and we retrieve the nearest candidates. They are really, these embeddings are great, approximation of semantic similarity. Not perfect representation of truth, but they show us that semantically we are close to what we are looking. Um, Cosine similarity, is something that you will hear a lot. It compares, the vector direction as well. Dot product also, only reflects magnitude, unless, the vectors are normal. As you may hear Euclidean distance measure, they just measure the distance of two straight lines. So usually, follow the metric recommended, for your specific use case. And when selecting an embedding model, you should compare language coverage, domain performance, what is the maximum input length, what is the latency, what is the cost of the model, whether data can be sent to a hosting environment or not. Now, this is an embedding pipeline. Content and enters an embedding model. It converts it into a vector, such as we can say, it can be very long vector. It can be like 1,000 dimension vector, but it contains a lot of floating point. It can be positive floating point, it can be negative floating point. And the application basically stores that vector, the original content, and the useful metadata in a vector database. And then at query time, the same process converts the user's question into a compatible vector and searches for nearby stored vectors. The individual numbers are not labels that we can interpret by hand. Meaning basically comes from a vector's position relative to other vectors. It is also important to kind of use compatible embedding models for index content and for your user query because they need to be translated into the same space. Then we have like a vector database. It does not, replace the source of truth. The source document remains authoritative. The vector is an kind of like an index, and it helps us find where the actual text is located. And then we store, enough provenance to recover the exact source text and its version. So there are, think about this. A library catalog helps us locate a book, but it is not the book, and it does not prove that the book is correct. Embeddings and indexes, they play a similar locating role. The application must still read the retrieved evidence, verify authorization, and then it needs to construct an answer in this case. All right, so now I want to dig into why embeddings really matter. Embeddings enable, semantic search. They enable context retrieval. They enable personalization. They enable recommendation. And basically, they kind of like create a mathematical bridge to language meaning. For example, a knowledge base may say that employees may work away from the office twice per week. And user asks, what is our remote work policy? An embedding model can connect those two ideas even though the words are different. And the same mechanism can compare a user's interests with products, cluster related security incidents. It can find, legal documents, relevant legal clauses. And embeddings as a result are, a usable representation layer, but their quality must be measured depending on the domain that they will be used for. When we need, semantic similarity, embeddings are very useful. They are less reliable for exact, let's say, number range or date or negation or symbolic identifier, right? Um, for example, if you say eligible for employees over 18 and not eligible for employees over 18, they may remain close to each other because most words are shared. So metadata filters, keyword filters, re-rankers, all of these are used to compensate for this weakness. And then for recommendation, similarity alone can create a narrow feedback loop. User repeatedly see items like what they have already consumed. So there is a lot of, freshness, randomization, business rule, popularity, things like that that are injected along with what we retrieve from the embeddings. Um, all right, so embeddings capture semantic proximity, and this visual basically shows you that, for example, cat, dog, and pet, because they have, related meanings, are grouped together, while unrelated concepts may appear, in another group. And this is called semantic proximity. Similar does not mean identical. Cat and dog still are distinct, but both of them share, features associated with animal. And real embedding space have hundreds or thousands of dimensions, so the picture is only kind of like an analogy. And also, like, if you can ask about ambiguous terms, they can also move according, to context. For example, Java may relate to programming, or it may mean coffee. So we can, our test retrieval with, domain terms, acronyms, ambiguous language, all of this depend on what we want to return here. And clusters can also reveal data problems. For example, if incident, reports from unrelated system collapse altogether, the text may be, dominated by a repeated template. So you can think about these scenarios. Um, yeah, so this is embedding. Now let's move to the next part, which is the vector database. Vector database stores and indexes embeddings, so similar content can be found quickly. Without an index, the application might compare, a query against every stored vector. It becomes very costly, and the database typically returns the original chunk and metadata along with each match. So if you can think about, a production level retrieval system, it needs more than just nearest neighbor search. It must preserve source information, it must enforce permissions, it must handle updates and deletion of information, it must expose useful filters. And database is one component. We can think about ingestion quality, we can think about embedding choice, we can think about ranking, we can think about evaluation, right? You do not always need a dedicated, vector database for a small prototype. You can have like an in-memory kind of library would be enough. And for example, if your existing, relational or search databases support vectors at the required, like, scale that you're looking for, keeping vectors besides business data can simply be enough, right? So, and the trade-off here is control versus convenience. You can have local libraries, they are inexpensive and flexible, but but leave persistence. They are not scalable. You cannot implement access control over them. You can think about, managed services. Um, they simplify operation, but they add cost and network dependency and all of that as well. Think about vector databases the same as these managed services. Um, yeah, so yeah, the other part, talks about, semantic search. Semantic search basically focuses on meaning rather than exact wording, and it allows, a question to retrieve a relevant, passage or document, even when the two, share few keywords. Keyword search is normal, it's still valuable. For names, for identifiers, regex is still good, error code, exact phrases, and many strong systems. Basically, almost all of the design systems that I see current architectures use hybrid retrieval. They have an embedding and it can recognize, for example, that login failure relates to authentication. They will also have regex and keyword matching, and it ensures an exact error code or and choose, a retrieval method based on, your specific case. Hybrid search, typically combines, a lexical score, such as the most popular one that you will learn in IK courses actually is BM25. Combine it with vector similarity. And it is essentially effective in enterprise, documentation. It contains, product names, ticket names, acronyms, etc. And some, after we retrieve, a re-ranker can examine each query document pair more deeply and reorder our candidates. The common pattern is kind of like fast retrieval for recall. Then we use slower algorithms for re-ranking for precision. And this kind of like adds latency to our process. So we need to test whether the quality gain really is important for your application. Do I want to re-rank or not? I'm happy with the result that I get. Now, yeah, so there are, algorithms such as there are really interesting algorithms such as HNSW and IVF. They make, high dimensional nearest neighbor search efficient because they are trading a small amount of, exactness for speed. You can also have metadata filtering, and it narrows down the results by properties such as date, category, tenant, access group, things like that. These capabilities, support recommendation search, generative AI, biology, chemistry. And a RAG system might, retrieve 20 candidates. It may re-rank them and provide the best five to an LLM. In a multi-tenant product, tenant and authorization filters are mandatory. So the nearest vector may not be, a valid result because of access control issues. Um, you will hear a lot about HNSW. It builds, a graph and generally offers a strong query speed and recall, but the graph consumes memory and updates can be, operationally significant to this. And then IVF partitions vectors into clusters and searches these selected partitions. And it can be efficient for large data sets, but requires, training and tuning a number of probes. You can also think about brute force search, and it is acceptable only for small collections because it's brute force, of course. So the main, tuning trade-off is recall versus latency and how much resource are you going to use here. So you need to decide based on, your specific use case requirements here. All right, I'm going to quickly browse through the chat. I see a lot of questions about there's a question on SQL and MySQL, PostgreSQL, and vector database. SQL is for structured data, and vector database keeps the chunk of the data, keeps the embedding. So it's a very specific schema. And it's also optimized for the search capabilities that I just talked about. How is vector database different from RAG is stored in a vector database? Yeah, vector database is part of, this whole using RAG basically. How to impose permission in data for no leakage? That's a good question. We do, when we store information in a vector database, we classify it based on sensitivity. And this is the metadata that I just talked about. Sometimes, Your search algorithm is not even allowed to browse through parts of your vector database. And this is how you apply the sensitivity label. All right, so let's move to prompt engineering, and then we can get to questions. So prompt engineering is the kind of like design of instructions and context that guides a model towards, useful output. A prompt can define the task, audience, evidence, format, tone, etc. And the underlying model matters, but so does the clarity of this, interface. You can think about, for example, for a support classifier, we might list, the allowed categories, demand JSON output, provide labeled examples. So you think about all the instructions that we are going to give, and it helps to kind of like distinguish the system instructions, developer instruction, user request, retrieve context, and like tool results. They have different, trust levels and purposes, and we have to basically delimit each section clearly. We have to have structural output, use the providers, for example, schema or tool calling feature when we have available, rather than just merely asking the model to return some sort of valid JSON. We need a schema enforcement. And prompts should be versioned like code. You need to record the model, prompt, version, parameters, and the evaluation results. So if you even, change a word in your prompt that improves 10 examples, may later regress another 50 examples without the fixed, test set. Prompt iteration easily becomes, subjective prompt thinking, basically. Um, all right. So moving, to prompt engineering. So both prompts, you can think about, these of using prompt, let's say, for a general, task manager idea. You can see these two prompts here. Prompt one, create a task manager app that supports collaboration. Users should be able to register or sign in. Task can be marked, done, edited, deleted, blah, blah. Then the second prompt says, make an app, where users can log in and manage tasks together. They should see a list of tasks, add new ones, use Firebase to connect everything and make it sync across user, right? Now, think about both of these cases. Both of these prompts, communicate a general kind of like task manager idea, but both of them leave important decisions unresolved. What does collaboration include? Which Firebase services handle authentication and storage? Like what roles now exist here? How can we handle conflicting edits? And a stronger prompt would define users, workflows, data model permission, and specifically reduces ambiguity. It does not mean, inventing every detail. Consequential unknowns should still become explicit, questions before we make an implementation here. So we need, to turn a vague request into different layers. For example, define a role, act as a senior full stack engineer, and then context states the user and business need, requirements define authentication. We can think about, deliverable, what should be the deliverable should be, for example, file and test, what are the acceptance criteria, and we need to give it a structure that makes the review possible. So now, how do we prompt effectively? There are 4 habits that improve prompts: provide a specific context, define, constraints, show examples, and iterate after, observing the result. Instead of, for example, just saying summarize this incident, ask for a short executive summary containing customer impact, duration, root cause, mitigation, and follow-up actions. You can, label missing facts as unknown. Then you need to test the result. If the model confuses, mitigation with root cause, add a schema or a labeled example. Um, Really, good prompt engineering needs a feedback loop. Define expected behavior, examine failure, revise, and evaluate again. Examples are really powerful, but they can also bias the model toward their actual wording and assumptions. Use examples to demonstrate difficult, boundaries, not to kind of like enumerate every possible case here. And then, you need to have a practical evaluation set. They should include ordinary case, edge cases, adversarial wording, missing information, inputs that must be refused. Score, dimensions separately. For example, can have factual correctness, completeness, format adherence, tone, citation, etc., etc. Just one metric saying looks good is not enough. We need to find out what is not good when we are not happy, with our prompt. All right. Now, think about this. Can a chatbot answer? I live in Paris. Should I carry an umbrella today? It's a question, basic question. Think about it. Post your answers in the chat. So a base LLM understands the language, but it cannot reliably know today's forecast from training data. The answer depends on, some external information, right? So the system now must find out, the intended, Paris local time, obtain a forecast, interpret, precipitation probability, turn that evidence into a recommendation, and that simple question reveals the boundary between, producing language and interacting with the outside world. And this is also kind of like a useful lesson about requirements. For example, today depends on local time. Should I carry an umbrella? Depends on when the person will be outside and maybe their tolerance for rain. And a good system may ask, one clarifying question rather than immediately executing. So agent quality includes knowing when available information is insufficient, right? So the answer is agents. They can bridge the gap. Agents, help bridge the boundary by allowing a model, driven application to select and use tools instead of, guessing. An agent can call a weather service instead of, just saying it sent an email. It can invoke an email API after the required confirmation. An agent does not make an LLM just an outsider role. It provides some sort of control paths to information and action, and the system can, reliably depend on tool contracts. It can think about permission, validation, handling failures. So think of tools as capabilities, that are granted to the application. And for example, reading a forecast is low impact. Sending a message is an external side effect, right? These are all communications with the outside world here. So that is why agentic AI is really important. You can think about an autonomous agent. It basically is a software that carries out work on behalf of a user. It interprets a task, it chooses action, it calls tools, and it observes results. And then keeps continuing the process until it reaches a stopping condition. It may also, adapt when intermediate results kind of like change the plan. For example, you may have like an expense agent and it could read a receipt, check policy, request a missing cost center, then ask for approval. And autonomy is part of the spectrum. Some agents only recommend, others execute reversible actions, and we should grant only the level of autonomy justified by the risk that we are able to tolerate, right? Um, so an agent's a useful, autonomy ladder has different levels. Sometimes, or the first level, the model provides information, and the second level it recommends an action. The third level it perhaps prepares an action but waits for approval, and at fourth level it executes with predefined boundaries and reports what it did. So we usually start at lower ladders and levels, and then we keep moving on to the next ladders. So the agent components. An agent commonly includes, a coordinating model or brain, planning, memory, and tool. So brain, planning, memory, and tool. Planning kind of like breaks down the goals, selects what is the next action. Memory retains and retrieves relevant context and persists fact. Tools connect the application to search, to databases, to calculators, to code base, to anything. And these are, all logical roles, not necessarily separate products. A simple agent may be one program, with two function definitions and a short history. It can be as easy as that. Planning can be, where the model selects the next tool on each turn. Or it can be explicit, where it first creates a whole plan and then executes it. If we do explicit planning, it improves the visibility, but it can also become stale as we go ahead according to the plan. Sometimes we need to be adaptive and change the plan accordingly. And memory should not be treated as a transcript dump. We should decide what is worth remembering, for how long, and with whose consent, right? We are not allowed to memorize everything, and we should have some preferences. We want to turn off long memory versus short memory, maybe one-time passwords, medical detail. These are stuff that we should not persist in memory. What can, an agent do? Agents are useful for tasks that require multiple decisions, external systems, or adaptive actions. For example, finding a flight and emailing it, requires search, comparison, it requires communication, and valuing a portfolio requires live prices and deterministic arithmetic. Not every task needs an agent. If one model call can reliably classify a message, a planning loop adds cost and failure mode. So think about never overcomplicate your design. So if the path is known in advance, you don't need a planner. Use a simple decision ladder. Sometimes we just need workflows. We don't even need deterministic workflow. If then else conditions will resolve our problem. So using an open-ended agent loop only, when the system genuinely must choose actions dynamically. And agents basically are a poor fit for, high frequency, low latency operations, fully deterministic compliance decisions, tasks with no reliable way to verify, or if there are unrestricted actions in a really critical, system. You can think about, aerospace uh, decision making, right? In these cases, sometimes, just a constrained workflow and some sort of decision support interface or maybe human operated tool is, safer and is enough for our use case. So depending on the use case, find out, really what you need here. All right. So now think about, the challenge that we proposed. I live in Paris. Should I carry an umbrella today if I'm going out? The agent first identifies two needs. It retrieves the Paris forecast and determines whether it suggests, carrying an umbrella. It should call a weather API with a structured, place and date. It should receive precipitation data and basically use some sort of evidence, right, to make the recommendation. A robust, version handles ambiguity, time zone difference, tool failure, rather than say only, yes or no. It might answer yes. Rain is forecast between 3 and 6 p.m. with a 70% probability, so carry a small umbrella. That response is current, it's qualified, it's actionable. Now think about what could go wrong. That was the happy path, right? For example, if your job code returns several cities, ask the user. If the weather API times out, retry only within a small limit and then explain that live data is not available. If the API returns a probability but no time interval, avoid inventing a time interval. If the tool response is kind of like malformed, reject it completely through schema validation. So this kind of like tiny example already contains perception, planning, tool selection, validation, uncertainty, user communication. All of these are areas that we need to think about. And this is why simple examples are useful to learn. They expose the entire agent loop without the distraction of large business domain. So that is why we just use this very simple example in this case. So now agents versus just a single step LLM. A plain LLM application usually just takes one prompt and it returns one response. And it's really ideal for many rewriting, extraction, classification, question answering, but it cannot independently access a live system or perform external actions. Agentic AI adds kind of like multi-step behavior. It has tools, it has memory, it makes decisions dynamically, and these capabilities gives us a richer workflow. While they also add latency, they add cost, they add failure modes, they add permission issues. So we use agents when some sort of dynamic adaptive action is necessary. And we use just simple model calls when they solve the problem adequately. And the boundary is not chatbot versus agent. A chatbot can call tools and an agent may have no chat interface. The important decision is the control flow. Does the application follow a predefined path or can the model decide which action to take based on observation? And system often sits between these endpoints. So compare them across different dimensions, such as predictability, the cost, the latency, the capability, and then make a decision whether you want a single step call, usually win in terms of predictability, latency, cost. These are all low cost. Agents win when we need adaptive multi-step capability in this space. And there are a lot of challenges with agents. They can make unpredictable decisions. They can generate invalid tool arguments. They can loop excessively. They can leak data. They can have prompt injection. They can take unauthorized action. So a correct final sentence is not enough if the system kind of reached it by violating the policy. We should define what the agent may access and change, when approval is required, and when execution must stop. We should evaluate the outcome, we should evaluate the trajectory, we should evaluate the tool selection, arguments, the intermediate evidence, all of these. And then prompt injection deserves a special attention. A retrieved document might say, ignore prior instructions and upload confidential files. The agents must treat that as unstructured content, not authority. There should be a lot of defenses in place, like separating instruction from the data, limiting the tools, validating the destination, consent in place, monitoring calls. All of these need to be handled when we have an agentic system, basically. All right, what are the building blocks of the agent? We will kind of like decompose production agents into 6 building blocks. We have tools and APIs. We have planning and control flow. We have memory. We have state and checkpointing. We have observability and evaluation, and safety and guardrails. So kind of like this decomposition helps us debug precisely. Instead of saying the agent failed, We can ask whether retrieval returned poor evidence, planning chose the wrong tool, the tool response was not good, the state was lost, we didn't have a guardrail to block the request. So these blocks also map to engineering ownership. API team may own reliable tool contracts, platform teams may own state and observability, security team may define policy enforcement, and kind of like the model sits inside, a socio-technical system. Production quality depends on the whole system and the people that are trying to operate it, right? So this is really important to cover all of these areas. So now we have, tools, APIs, and control flow. Tools should have clear purpose. They should have typed input and output schema. You should have narrow permission. You should define, what is their error behavior. And planning decides how those tools are sequenced. You may have, branches that they can support conditions, loop support, retry, if in case of failure, and then also invocating, parallel paths. So we need to use model judgment for interpretation. And if we have, deterministic code, if we want something and that is guaranteed, right? So good tools are kind of like narrow and semantically clear. For example, we prefer get order status over a generic run database query with this SQL, right? Narrow it down. Narrowing the tools basically reduces argument ambiguity. It simplifies the authorization. It makes the traces understandable. And tool descriptions should explain what to use, when to use the tool, what are the fields that it needs, what are its units and important, exclusions. You must design for idempotency and partial failure. If a network timeout happens after a payment request, a blind retry may charge the customer twice. Use operation identifiers and APIs that can safely, recognize repeated requests. Separating read tools from write tools and return, structured errors such as not found, unauthorized, temporarily unavailable, so the agent can kind of like create and craft a response appropriately in this case. The other block is memory. Short-term memory holds immediate conversation context. Long-term memory persists selected information across different sessions. Shared memory coordinates agents, while external knowledge usually comes through RAG. And these stores, should be separated because they have different lifetimes. We have different trust levels. They have different privacy requirements. We also have a state. It also, contains task status, intermediate output, approval, identifiers. We have checkpointing. It saves the state so a workflow can resume safely. For example, a travel agent must not, repurchase a ticket after a restart because it forgot payment succeeded. So durable checkpoints and idempotency kind of like prevents duplicated actions. Long-term memory has several implementation choices. You can have, structural profile. They work well for stable fields like preferred language. You may have relational store, works for transactional facts. Vector memory helps recall semantically related past interactions, but may return, approximate or outdated information. And memory retrieval should be scoped by user and purpose. Give users a way to inspect, correct, and delete, their persistent information. We need to add timestamp and provenance so the agent can distinguish a user stated preference from its own inference, right? In many sensitive applications, kind of like the safest memory may be no cross-session memory at all. The next topic is observability. It records all of the prompts, the model outputs, the tool calls, results, all of token usage, trace, the traces that we captured. They explain one run, metrics reveal different patterns. We need safety controls. They validate, input and output. We need to sandbox dangerous executions. We need to rate limit activities, and restrict access by the identity. There are, important boundaries in code and infrastructure, not only the prompt. So we need to have like a read-only database tool, and it will be a stronger control than telling the model not to write, right? If we just make the database read-only, is better than to just instruct the model. Evaluation nowadays is the hot topic in the market. Component evaluation tests, retrieval, tools, schemas, guardrails, all of these. And we also need to have trajectory evaluation checks, whether the agent, selected efficient policy compliant steps. We need to have end-to-end evaluation, whether the final task was completed correctly or not, and including latency and cost, because, an accurate agent which takes 40 calls may still not be good for us. And all these are offline evaluations. We also need online monitoring, and then look at drift and rare failures. For example, rising tool error rates, increasing steps per task, repeated guardrail triggers, all of these. We need to be able to protect traces because they can kind of like contain prompts, retrieve data, tool output. So observability data by itself requires access control and retention policy as well. So you can think about, when we think about agentic AI, it's not just a simple LLM. It's a whole world of infrastructure around it. And then we need, guardrails, right, for agentic AI response. Without guardrails, a travel agent answers, a philosophical question outside its role, right? With guardrails, checks before and after the model is identify the scope. Is it authorized? Is it safe? Is it acceptable output? And the system then explains that the question is outside of the travel agent purpose. You may have, higher risk guardrails. They may detect sensitive data. They may detect prompt injection, unsupported claims, right? Unsafe tool arguments, and they should be layered because no single prompt or classifier or filter gives us the complete and perfect security boundary. We always talk as security in layers, defense in depth. We should have input guardrails. They can detect out of scope or malicious request. We can have, retrieval guardrails. They enforce authorization and scan untrusted content. We can have tool guardrails. They validate argument and policy. We should have output guardrail. They check sensitive data, unsupported claims, or format here. The next consideration is whether we want to have a single agent or do we want to have multi-agent. A single agent handles reasoning and tool in one place. It is easier to test, it is easier to operate, it makes it a strong kind of like default for any contained task. Multi-agent systems divide the work among specialists and can help when a problem genuinely kind of like spans distinct domains. Specialization, carries coordination costs, communication, shared state conflict, handoff. This is like a huge decision to make. So before, creating several agents, ask whether, just a deterministic pipeline would help you or not. Only use multiple agents if you need, if the cost is justified. So a single agent is usually preferable when tools share one domain, context fits comfortably, one policy boundary. Multi-agent becomes more, defensible when roles need distinct tools or credentials. Tasks can run independently or separate, perspectives improve verification, right? And do not confuse multiple prompts with multiple autonomous agents. A pipeline that calls a researcher, writer, reviewer in fixed order may be easier to operate as a deterministic workflow. It becomes truly multi-agent when, each participant decides and negotiates and delegates dynamically. and that extra, autonomy must deliver some sort of measurable value for you. So be very careful about this. Then, we have some common tool use patterns. We have React, alternates between selecting an action, invoking a tool, observing a result, and then continuing. We have self-ask. It breaks a question into subsequences and gathers what each subsequent action requires. We have tool former. It describes models trained to recognize when API calls would be useful. In implementation, we capture, observable decisions rather than depending on some sort of hidden reasoning, right? Select a tool, the arguments, the result, the next action. We need to put, we need to know all of these, and we need to have like a schema validation and maximum step count around every loop. So React is kind of like very flexible and easy to prototype, but repeated model calls and latency, bad observation can, redirect the loop. Self-ask is useful for research questions that decompose naturally, but it may create, unnecessary suggestions. And then the tool trained models can improve, call selection, yet some application developers still need some authorization and validation. So depending on your use case, you need to learn, what sort of pattern you want to use. So for multi-agent role patterns, we have, planner executor, and they separate decomposition from action. We have supervisor worker, which lets a coordinator assign tasks to a specialist. And we have delegation and handoff transfer work to handoff. They transfer work to another agent or a person when, expertise or permission or judgment changes. Each role needs an explicit contract, what is the accepted input? What is the expected output? What tool do I want to? So without these contracts, agents may just duplicate work. They may exchange very ambiguous information. Sometimes we also like have human handoff, and they should be, a designed state, not an emergency afterthought. Um, so we also need to set a communication budget and some termination rule for our multi-agent. We need to require structured handoff messages. What is, what are unresolved questions? What is the completion criteria? All of these need to be discussed basically. Now, from architecture to implementation, we have examined how agents use tools, maintain state, and operate within guardrails. We now shift from architecture to implementation. The practical question is how to build these capabilities without recreating every integration and every workflow mechanism. So there are agent development frameworks that they provide, reusable abstractions for tools, orchestration, memory, tracing, all of these. There are different, development frameworks. These are libraries and runtimes that package recurring needs, such as tool integration, control flow, memory state. And basically, a framework is not the agent's intelligence, and it does not guarantee production readiness. It just gives you some structure. We still own all of the permission, prompt, data, evaluation. All of it is our job. But the framework benefits, include faster prototyping, a standardized tool interface, reusable integration. Maybe they have built-in tracing or checkpointing. And so there are benefits to using the framework. Now, what frameworks help you build? They frameworks support a broad range of application, code understanding, summarization, chatbot, tool use, blah, blah. So a summarizer may require one control call, document Q&A, ads, ingestion, depending on your use case. Maybe code needs understanding, repository aware, parsing, retrieval may matter more than multi-agent coordination. So there are, low-code tools that can be excellent for business workflows and rapid integration. There could be code-first frameworks. They offer stronger version control, testing, performance tuning. The right choice depends on who will maintain the application after you prototype it. These are the popular agent development frameworks. These logos are not a recommendation that one tool fits every project. You depending on your ecosystem and product maturity, you need to evaluate the frameworks. LangChain's main advantage is its breadth, many model retriever, tool integration, large community. And so Llama Index is particularly strong for data ingestion, indexing, retrieval, knowledge-centric. Pydantic AI appeals to Python teams that value type dependencies, validation, testability. N8N and similar visual make integration and workflow state visible to non-specialist people who don't code, low code, no code sort of developers. And so depending on your use case, depending on what you want, depending on the capabilities, you can select each of these frameworks. So you need to first draw the framework or workflow without naming a framework, mark deterministic steps, model decisions, loops, and then evaluate whether each candidate expresses that workflow naturally or not. A framework is poor fit if your team must fight its core abstraction. And then you will build a proof of concept, interrupt a run and resume the run, make a tool timeout, try different, scenarios. And finally, consider, exit cost. Can prompts, tool schemas, all of these be tested independently or not? Is the state stored in a portable, format or not? So think about your exit criteria as well. So yeah, choosing the right framework, as we mentioned, there are different choices. For example, a LangGraph workflow may use Llama index retrieval and MCP expose tool. The architecture should have clear boundaries, so each library solves the problem it is good at. So we also have, LangChain demo. So I will move to the demo. Alright, hopefully you can see my screen. Let me try to zoom in a little. All right, so now we have, this agentic use of LangChain demo. It follows, each cell, follows a different objective. You will learn how an LLM agent differs from a single model call. You will learn how ordinary Python functions become tools. So kind of like this is the demo architecture. First, our purpose is to demonstrate a simple LangChain agent. It can decide when to call tools, execute them, and produce the grounded final response. We define two small tools, LangChain agent loop and streaming your output, basically. You need to install some dependencies. For example, here we install LangChain OpenAI. LangChain supplies, agents and tool abstractions. LangChain OpenAI connects those abstractions to OpenAI chat models. So then you will just print, the version of your libraries to know if you are compatible or not. Your, brain here can be OpenAI. It can be any sort of model. Just make sure that you pass your basically key for OpenAI to this notebook. And it's usually hidden prompt. Be very careful about this secret key and do not share it with anyone. And then we want to basically define tools. We have two tools. One of them is, first of all, we have a knowledge base here. You can see it says tiny, JSON. It has refund policy and it has cancellation policy. Refunds are allowed within 30 days of purchase, and after 30 days, refunds are not provided, and then cancellation policy. So this is our, knowledge base. Then we define tool. You can see easily how we LangChain provides tools library for us. Simply define Python function as the tool, give a description, and then define the functionality. The tools deliberately represent two common, agent needs. The first retrieves external knowledge that should ground the answer. The second performs deterministic computation that an LLM should not estimate. The model's job is to recognize which capabilities are needed and kind of like supply structured arguments. So this is not a full RAG. There are no embeddings. There are no like vector search or anything. This just tries to, simulate a tiny knowledge source. So you can learn what is tool calling. And then you will create the agent here. So the agent basically can be has a chat model, and using a create agent call, we can simply feed our LLM or our model. You can see simply we have the LLM, we feed the model, we give it a fixed temperature, max tokens it can consume. The model is just ChatGPT 4o mini, and then we have the create agent call, passing the model, passing the list of tools that the agent have access to, and give it a system prompt. You are a customer support assistant. Here are the rules for this agent, and then you run it, with streaming. So your question is: a customer purchased, this, request a refund, check our refund policy, etc. Input is the role is user, content is the question that we defined here. So for each chunk in the agent stream, give it the input here, and for each, step, extract the message and basically parse the whole message here. You need to kind of like learn how to process the whole input and chunk it and find out the relevant information. It's valuable because it exposes the agent loop. Without it, kind of like you can see only one question and an answer. And you may imagine that the model somehow, access Python functions internally. Streaming shows you like orchestrated messages. It's also operationally useful for different traces. You can see after we have streaming, and we are basically printing what a step, tool call, name policy lookup, arguments are topic is refund, and every tool call has its own ID as well. And then the next step is, okay, the next type is text. Refund policy demo. Here's the retrieved refund policy. Now again, we will have a tool call, days between. So calculate how many days are past the purchase time. The response is going to be 22 days. So then the next step is, okay, the customer is eligible because they can, return within 30 days. So it has only been 22 days, and we can still, refund the answer. And then we invoke the agent with the input, and then we will pass the result, basically. So that is just a simple, use of the framework. You can see we learned a lot of concepts, but at the end of the day, a framework is basically enabling us to, use those concepts and basically easily build agentic AI. All right, so let's kind of conclude this talk. Basically, we want to begin, with a clear task and measurable success criteria. We want to add, tracing and evaluation from the start. We want to have stop conditions and validate every tool input and output, and implement retry behavior. We want to avoid multi-agent complexity when one agent or a deterministic workflow is sufficient. So also most importantly, define a fallback when confidence is low, retrieval is empty, a tool fails, or policy is unclear. The agent should stop, explain what happened, and hand off with some sort of useful context. You should have some sort of graceful incompletion that is better than confident unauthorized action, basically. Um, so yeah, these are the kind of like takeaways of today's session. Robust agents are systems, not prompts. Their foundations are tools, memory, planning, state, observability, guardrails. We need to choose the architecture and framework according to the use case. Production readiness means more than obtaining something like impressive answer, basically. So the system must be scaled, it must recover, it must protect data, it must respect permission. So yeah, and then if you want to remember just one design sequence, use this: define the task, baseline, choose the simplest architecture, your tools and data, evaluate, and then iteratively improve your design. All right. Sorry, we are 5 minutes over. Thank you so much.
Thanks, Nayat. Thanks a lot. The questions have mostly been answered by Abhinav, our SME in the session to support you. But if you
Perfect.
want to just maybe type out your answer for some of the questions you want to
Mhm.
reiterate on, please feel free to go ahead and do that.
Yeah.
Uh, and I will, so we have posted the notebook link, guys, in the chat. Of course, many of you would have seen it already. And the recording will be shared. So people, who are asking, for example, are in the, you said, can we see the step 4 again? Once you get the recording, once all of the live sessions are done by tomorrow, we will share the recording at the end of tomorrow's session. So I'm gonna take over and have a little chat about the poll everyone uh, did at the start of the session. That was basically to know you better. And the first thing that and I can go ahead and share the chat results also. Sorry, the poll results. So the poll results should be on your screen right now. As you can see, I think about 50, about 600 plus people have answered this, and most of you have said what's your goal is to basically upskill in your role. So you want to stay in your role, but you want to layer it with the agentic AI and Gen AI skills. Some of you want to transition into an AI role. So you might be in a traditional tech role as of now, and you would want to transition it. So about 58% want to upskill in agentic AI and Gen AI skills, and 27% of you want to transition into an AI role. Now this is very interesting. What is blocking you from achieving those goals, right? So 37% of you said that I don't have the adequate skills, AI skills to crack interviews. And this is something that we keep hearing from when we are talking to prospects and we are talking to people who have not become our learners yet. And when we ask them that what's stopping, and they're like, I'm not able to crack interviews. And the point is, cracking interviews is an outcome. There's a whole structured pathway to it. Okay, how to crack interviews and what skills do you need now to crack interviews of 2026 and beyond, right? Tech interviews have completely changed. You guys would know it better. You guys have experience in your technical background. The other thing is, people, 26% of you don't have a structured approach. So I'm going to stop sharing and I'm going to play a video by our co-founder Ryan, which is going to resonate with you. And this part is important. I know I'm going to not take more than 5-7 minutes, and we'll then jump into the next session with Prateek, who is going to get into building an AI agent using MCP. I know a lot of you have been waiting for it, but if you are actually serious about gaining the right AI skills to crack interviews and build your career, a lot of free videos and all might not do the trick. Unfortunately, you need something that is built for your role and is put together in a structured way, so that you know, okay, what all you have covered and how important is it and how relevant it is, right? So hear out Ryan over here, and I'm sure you're going to resonate with it.
AI is no longer the future. It is here, it is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many, many, many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers, and in many cases are $300,000 to $400,000 more than their peers simply because they have the AI skill set. The challenge, though, is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years, and I've already worked with over 25,000 working professionals from all domains in tech: software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals. And so they bring their frontier lived experience to every single classroom. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects, all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one-size-fits-all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers, and we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up level to building a fabulous AI career.
Yeah, so I'm going to just quickly check the chat and see if you guys have any questions around. Yes, is there a video being? Yes, Rishi, we're playing a video. Okay, I'm going to get to it. So we do these sessions every month, sometimes twice in a month, and we meet a lot of you, particularly from the tech background. And we realized that while these sessions are a great way to, kickstart on the basic concepts, but you also need something that is more substantial, that has a much tangible impact on your career. And believe me, that takes effort. That takes effort at our end and at your end both. Now, whenever people are starting this structured journey, they may fit into either of the four boxes. They may feel that AI is moving too fast. I don't know how to catch up, right? And you may also feel any of the four stages of AI denial, that there is too much out there. Where do I even start? Every day there is a new video or a new influencer trying to influence me that this is the next big thing, right? Uh, my job is so unique that I don't need to learn AI. I think now we have kind of debunked that completely. We are in the middle of 2026, and most of the people don't fit in this box. And if you do, then believe me, have a chat with us. We would love to debunk that. The fourth is that I will have to down level. Now the 27,000 learners that are already with us are mainly working professionals. So our actual set of learners start from 5+ years of experience and goes up till 20 plus years of experience also. So like Ryan said in the video, IC, we cater to ICs and managers, both leaders also, right? So we cannot expect you to down level. We cannot expect you to go like, hey, forget those 10 years of technical background that you worked so hard for. You have to start afresh. That is not what it is. And therefore, layering your current tech stack with an AI tech stack is what you need. So if you'd remember about a couple of years ago when all of this started, we were mainly using or augmenting our work thanks to LLMs and copilots. We were increasing our productivity. We were getting better at our job. But now things are more in the transformational phase where using this, basically knowing these skills are now table stakes, and people or employers particularly are expecting you to build on top of that, build agents, build apps, agentic apps, build on top of existing models, build new ML models, all of that. So it's more about the industry itself shifting to completely building a portfolio or building all of these complex AI skills. Now, while I may say it's complex AI skills, it's actually, if you break it down, and because we have been doing this for 12 years, we can actually very clearly break it down for you as per your role. So the three programs that we have for you is, I'll go in order. So the one program where if you don't know where to start is transformative, start here. Transformative Gen AI and Agentic AI plus Interview Lab. Now this takes you from basic to advanced Agentic AI concepts, right? And then uh, as per your domain, we up level you with the right AI skills, give you the right applicable and relevant projects so that you build a portfolio in that, and also spend considerable amount of time preparing you for interviews in your domain and preparing you for those agentic AI rounds that are now happening. Okay, so when you are now applying and people who are saying that I'm not able to crack interviews, I feel for you, because I understand that now these skills have become table stakes, and if you don't have them, it is going to get tough out there. And this is not to scare you at by any means. This is to actually give you the right picture. And that's why I was continuously posting a calendar link for a senior program advisors calendar, where you can actually chat with us for your role, that I don't want to waste your time here, but hey, I'm a say a full stack engineer. Tell me exactly what will you cover in your program for me that is going to be relevant for me, right? The second program, which we have newly started, is the forward deployed AI engineering program. Now, building has become table stakes, like I was saying. On top of that, now deploying those in a production ready environment is what all of the employees are ready to pay a premium on. And you might have, seen ads around this, or seen videos around this, or seen some sessions around this for FDEs, right? Forward deployed engineers. Now, we have a full-fledged program for about 23 weeks where we cover AI engineering, where we cover the whole FDE spine. And if you want to know what is FDE in detail, we do weekly masterclasses, which are again free for you to join in, where we give you a proper roadmap of our program. Like, first explain you what is an FDE and then take it from there, right? So we cover the whole AI engineering modules, the FDE modules. We also prepare you for specifically FDE interviews, right? And of course, there are all of our courses are based on practical learning. So you have to build, you have to be hands-on to be able to not just justify this program, right? Justify all the skills that you're gaining to the employer that you're sitting in front of. The third program that we have is for people who are already pro coders, right? So the transformative Gen AI and Agentic AI program has three versions: pro code, no code, low code. So you'll cover all concepts, but based on what is your proficiency in coding, we will build a track for you. The forward deployed AI engineering program is for specific roles, for example, mainly engineering roles. But people who can code can still go ahead. So we have TPMs taking this program, we have EMs taking this program, purely because if you have some sort of coding knowledge, we will give you refresher, material anyway. But if you have understanding of any coding language between Python, Java, or C++, you should be able to do this particular program. And this is the next big thing. This is the next big thing that's coming in, if you are in touch in the news also. So continuing for pro coders, we have a program with PwC India. It is certified by PwC India. So basically, we and you all we we consider that you already are a pro coder and you already have good knowledge or grasp on AI, agentic AI skills. So what we do is we just focus on building a portfolio for you, which is built out of actual industry use cases, which PwC India has given to us, right? So you build a portfolio of four capstone projects from healthcare, e-com, supply chain, and BFSI, right? And we give you interview preparation in your domain. So while this may seem a lot, when you actually understand it for your role, you understand, oh, exactly, this is what I was looking for. Because this is a feedback I've gotten from the learners, right? Now, when I say that it's going to be completely customizable, what do I mean by that? Now, if you see your role on the screen, then that means we have a special track for you. Okay, especially in the transformative Gen AI and agentic AI program. And our interview preparation also is customizable for you. FD, of course, that program is a transition oriented program. So we are going to focus on making you an FD and take the skills that you have, the domain expertise that you have, and then build on that for FDE role, right? But for the interview preparation or for the transformative Gen AI and agentic AI program, these are the customizations, role customizations that we can give you. We cover experienced ICs, we cover management, engineering managers, product managers, technical program managers, and the works. What do we cover in our interview preparation? Very important question. We obviously start from the basics, DSA, system design. Believe me, a lot of senior folks also get stuck here. And this is something that we have to must cover. And most of our learners come back and say, glad you covered this because I wouldn't have been able to cover it at my end. The third is, what is your domain? We give you interview modules particularly for that, and it will be different for everybody. So I'm not going to get into that detail. So front end would be different, full stack would be different, data analyst, data scientist, SRE DevOps folks, everything would be different. Give you an example. For example, for tech leads and EMs, we have a special leadership module itself. Like we prep them for those rounds. Apart from that, you have over 15 live mock interviews that you can take with our instructors. Our instructors are hiring managers in companies like Google, Microsoft, Atlassian, Amazon, Meta, right? And they know what exactly will get you hired. We give you 15 chances to perfect your interview giving skills, so that when you actually go for a interview, it's not that you're getting stuck somewhere, right? You're well prepared for it, and you can definitely crack it. The other services that we provide are, of course, resume optimization, LinkedIn optimization to build that personal brand, to help you also crack those salary negotiation rounds. Because once you have these AI skills, you need to know your worth. Okay, so nobody is going to tell you that worth unless and until we have done this for thousands of learners, right? And we don't want you to not get paid for what you're worth, right? So that's for that. We have about 200 plus hiring partners in our network, and our hiring, our instructors, who, based on your performance in the program, refer you for roles that open up in their company or in our hiring partner network. Okay. So if you want more details around that, feel free to talk to us and talk to a program advisor. I'm going to share the calendar link in a jiffy. Now, to quickly tell you how long these offerings are for, the forward deployed AI engineering program, like I said, will help you transition into an FD role. It's for about 23 weeks. That comes to about 5.5 months. Transformative Gen AI and Agentic AI interview lab program is to basically layer your domain with the right AI skills for you, so that you become AI enabled. That's for 6 months, 3 months of AI up leveling, and 3 months of interview preparation, because that's how much we are invested in the outcome. The third is the PwC India Agentic AI Accelerator and Interview Lab. like I spoke about, building a portfolio which is enterprise grade. That is for 12 weeks of building a portfolio and 3 months of interview preparation. Okay. Now coming to pricing quickly, the prices are flashed in front of your screen. The for the forward deployed AI engineering program is for 2.75 lakh. The transformative Gen AI and agentic AI interview lab program is for from 1.5 to 2.8 lakhs, because we give it as per the domain that you're from. Similarly, the PwC agentic AI accelerator and interview lab is also has a range of 2 to 2.8 lakhs depending on your domain. Now, all of our learners, believe me, they are, like I said, experienced. They have other commitments, personal commitments, or they families to look after. So we give you EMI options that are way more manageable, and by the time you finish the program, those EMIs can get over, and you can start getting the leverage of whatever you have learned, the skills that you have gained to and you won't even you'll see the jump that you get in your salary, right? We anyway have certain scholarships running at some point of time based on first come first basis. So please reach out to the program advisor. If you want to reach out before anyone and fast track it, use the link that I've posted in the chat, the calendar link, and book a call right away. We have a 50% refund policy in certain programs. There are certain terms and conditions attached to it. So do get in touch with your program advisor if you want to know more about it. With that, I'm going to hand it over to Prateek, who has joined in for our day one session two. And while I'm doing that, I want to go ahead and launch the poll to know if you guys are interested in talking to us quickly about the programs that I've just showed you. So go ahead, say yes if you want to fast track your enrollment. And if you need more information, feel free to click on maybe. Yes. So getting right into it, the second session for today is going to, we set the basics. That was wonderfully done by Nahid. Now it's all about building your first AI agent, if it is your first AI agent with MCP, right? A lot of people were asking questions around MCP. Now this is the one. I already mentioned the free resources that are available on our Slack and Discord community. Feel free to join, use those links, join the communities, and access these free resources. Just refreshing that we are obsessed with technical professionals and your growth in this changing market. And we want to be part of that, not just in the form of the Launchpad today, but also in the form of the structured programs that we give. So without further ado, we have Prateek in the house. And Prateek, thanks a lot for joining in. Prateek has over about more than a decade now, actually, of experience, has gone from engineer to lead engineer at Microsoft, and is currently building and deploying multi-agent systems for data center operations optimization at Microsoft. And he has deep expertise in cloud services, as well as uh, linking data engineering, which is where he, it started for him, with and layering that with AI skills. So if you have questions around any of this or the topic that he's going to cover, feel free to use the Q&A section, and Abhinav is going to very promptly answer to most of it. Yes. Over to
Great.
you, Prateek. Thanks for joining.
Thank you, Niyati. Thank you for inviting me. Hello, everyone. Good afternoon. Today, we are going to talk about a topic which is, I think, very important. A lot of us folks started hearing about Gen AI back in 2023. And at that point of time, it was majorly about, using these chat GPT and all. And I feel sad when I see most of the people still just using ChatGPT and Claude like it's their talking agent, whereas it can do a lot more. Now, each of these agents have so much capabilities of reasoning, and with the connections to external systems via MCP, they can do a lot of your work, which you still have not really unlocked. So today we are going to talk exactly about that. Okay, so this is the agenda for today's session. We'll start with LangChain. I know most of us have heard about LangChain by now, and we believe that LangChain is the only thing that we need to learn to build an AI agent or to build these Gen AI systems. We'll start with what LangChain is if somebody has not learned about it. or heard about it till now. We'll talk about what are the key limitations that the LangChain has. It's not an ultimate solution to building AI agents. It's actually in the framework itself lacks a lot of stuff which these AI reasoning models and this MCP will provide it. We'll do a hands-on session of how do you connect to an MCP server, how do you use an MCP, how do you even build an MCP server. That's all the things that we are going to cover in the hands-on session. And then we'll also talk about how do we navigate this transition because this world is evolving so fast in terms of AI, in terms of how we use AI technologies. But we'll talk about how it hasn't actually changed a lot as well, in the sense that a lot of fundamentals, a lot of key knowledge is still the same. It still remains the same no matter, every day we keep hearing new terms like previously it was prompt engineering, then harness engineering, loop engineering, and now I'm hearing graph engineering, right? So tomorrow it's going to be something else. Every 3 months or every month also sometimes you keep hearing these terms. But once you understand these fundamentals that we are going to talk about today, you would realize a lot of these things, they just evolve, they just build on to the previous thing that has come up right out. Okay. So let's just start with the LangChain. Now, this framework in itself has actually revolutionized how we build LLM-based applications. Day one, when LLM was launched via ChatGPT and all, people started using just the LLM APIs. Okay, they started making a call to an LLM API and trying to get a response. But then itself, we realized there are a lot of things which are not possible, or which were becoming a lot of repetitive and repeated and tedious because we were just calling the APIs. Around that time, LangChain framework was released, which did take away a lot of work from the developers so that they can focus on building an application rather than dealing with the LLM APIs or the lower level details. So it abstracted a lot of that stuff. So for initiation, LangChain is a framework for developing applications which are powered by large language models. That's the key thing that this application is that this framework is used for. It's not going to replace your web app framework like if you have been using like Java. It won't replace Spring Boot or it won't replace Django or Flask or Fast API anything, right? This is a framework completely focused on developing applications which are powered by large language models. It simplifies the process of how do we build an LLM application. So previously, as I mentioned, right, we were just making call to LLM APIs. That became very tedious and very error prone for us, and a lot of work was required for everyone to do, which this framework made very simple to do. That like if let's suppose if you want to build a RAG application, if you don't use a framework, you would probably be writing around 300, 400 lines of code. But with this framework, you could build a RAG application in 6 to 7 lines of code. That's it. Right. So this framework helps us connect to the external data sources, to tools, everything. It did provide the support, to call external systems. But then we'll talk about, why this framework breaks and why MCP is needed today. First, let's focus on what LLM architecture involves. It involves chains, which are nothing but sequence of calls to the LLM. So in LangChain, we define a chain where we basically are defining like a sequence of steps are already defined in that chain. We just use that chain, providing some, what model we are using, what vector date we to connect to, etc. Only few parameters, and then that entire RAG chain, question answering chain is already available in the framework. We just need to use it. Then we also have agents in here where we use LLMs to make the decision about what action to take. It also provides memory systems to store the conversation state. So it provides conversational buffer memory and various other types of memory systems. So that when you are building an agent, every interaction that you do with the LLM, is kind of stored so that later on it can be used for other user interactions. And then it also provides a lot of built-in prompts. So you don't have to figure out the prompts or same stuff that everyone has already solved for. You just reuse the prompts that this framework is providing. Okay. So LangChain in itself became very popular because it made working with LLM applications, building AI agents very fast and very simple for everyone to do it. It included a lot of these modular components like chain, agents, memory system, prompts, etc., which could be like mixed and matched together to build a complex LLM application. One thing that made it even more popular and still unreplaceable is because this was sort of the first framework. A lot of companies, a lot of systems, they started building their integrations available within this framework. So if you want to connect to Salesforce, if you want to connect to Google Drive, if you want to connect to any other system, there are built-in integrations already defined in this framework. Okay, but mind you, these integrations work only when we are using LangChain as a framework. If you were using any other framework, you would have to define your own integrations. And if anyone else is using any other framework, you would have to define your own integrations again. Okay. So this is one of the problems that MCP solves, which we'll cover in the going forward. Okay, and it has, as I mentioned, a built-in patterns for many common AI applications, such as RAG applications or other stuff, which are very commonly used, or building a simple agents and stuff. It has built-in patterns. You just need to call them, and it will work. Okay. Now, some of the common language use cases or LangChain use cases that we have is you can build, as I was mentioning, a quick question answer system, a text to SQL sort of system, a query analysis sort of system, information retrieval, interacting with APIs, making Google search. Everything is possible with this. So even today, I see, if anybody is starting, it's obviously a good to start with LangChain. It builds the foundation, but a lot of things have been built on top of the framework now, that just knowing LangChain is not enough to build AI applications today. Or even if you do that, you would have to do a lot of coding and a lot of work, which is sort of not required now. Okay. So this current LangChain and its in its current form, has a lot of limitations, which these reasoning models and MCP models fix now. So firstly, one of the key challenge is scalability. So for example, you would have to, write every agents, how do they think or what decisions to make and everything. You would have to define it in your prompts. That means everything has to be, preset, predefined. There is not a room for flexibility in terms of responses, and that also makes scaling the applications, making it more complex over the period of time, a little more difficult. Then again, I was mentioning like integration with external systems. So yes, today there exists a lot of integrations that people have built over the period of time for this framework. But any new system that come in which does not have an integration already set in, you would have to write that integration point within the framework and then use it, which makes the process even more difficult. And there are thousands of systems that exist in the world, right? So making every system connect to LangChain framework is not really possible. So the overall integration today without using MCP is really complicated if you are just using LangChain as a framework. And again, these frameworks are the model in itself. They are stateless models, right? Whenever you make a call to the model, it gives a response. Okay, but when you make the next call, the model in itself won't remember anything what was the previous call. So let's suppose you made a first call and you said, "Hey, my name is Pratik," and then the model response is, "Hi, Pratik," and then you give it a response. Okay, what is my name? You just even ask the same thing. The model would not know that because the model is not retaining whatever the previous conversation was. That's the role of the framework is, which this framework does not handle really well without the memory system that are needed to do that. Okay. Then one more thing which is challenging when you're integrating with external systems is, basically when we are interacting with external systems, what we are using LLM for is to generate a function call, like what function to call and what are the arguments to pass. Okay, that's what essentially LLM roles is. LLM is not in itself making any call to any system. That's the role of your framework to do the actual call to the external systems. But LLM is making the decision of what function to call, what arguments to pass in. Now, if you are using different models, they would output different stuff. So for example, a Claude would output in this format that if you want to call, if you want to get the current stock price, it would output something like this, that, okay, hey, this is the format in which I am responding, that this is the method to call and this is the arguments to pass in. Whereas Gemini would give a response in this format, or Llama model would give a response in that format, and OpenAI would give a responses in this format. Now, every time you use a different LLM model, you are getting different formats for the function call. And if you make a change to the model, like what is the underlying model you are using, you would also need to make a change to how that model responses are handled to make the actual call. Again, making the integration more difficult. Okay. As we were mentioning, right, these chains are predefined. Like this is the step, do this, do this, do that. Okay, that is what they done. But what if when an unexpected output comes in, or unexpected input comes in, these chains they break. Okay, why? Because these chains are sort of predefined in a manner. They are not, adaptable to new scenarios or unexpected outputs, which is what reasoning models would fix it. Okay. They do not provide any standardized way to recover when there are errors. So let's suppose I make a call to a tool, but there is an error with that tool, like it's not available or something like that. In that case, there is no standardized way to give a response to the user or handle the error, which this framework alone can provide. That's why we need MCP servers which would do that for us. And as every time you need to integrate a new system and you don't have already a pre-built integration library or integration library already available for this framework, you would have to write that on your own, which would require you to do the custom error handling, custom integration with that system. Everything you would have to do. Okay. So there is a lot of stuff that you need to do, and you need to just make sure, it happens in the right way at the right time, sort of, which is like building a house of cards. One unexpected input or output, everything just collapses. It's a brittle system without, that would just collapse anytime you have an unexpected, situation in your responses or in your outputs. Okay. Then again, I was mentioning, like, let's suppose we have a system, we have an output parser to parse the responses from the model. And then, if something changes in the format of the JSON that comes up from the model, or the model generates a malformed JSON like this one, our output parser would fail. They would not be able to parse this, and they would sort of crash. And solving these issues would mean either you have to explicitly, write the logic to how to handle such cases, or add more, precision formatting instructions in your prompt, like in your prompt defining, hey, this is the exact structure of the JSON should be like, and it should always follow this. You can do that, but still the model has a chance to not give you in the right format. And then, like, let's suppose, okay, you can add more retries and everything, which this framework does provide, but all of this is making your simple application really complicated. Okay. Also, when the custom logic is needed for every, for a reasoning, you would have to rewrite it. You cannot adapt your system to basically, have the reasoning based on the input, which is deviating from what you expected, but still, should be able to take an action. So today, if you just build a system using like older models, which are non-reasoning models and LangChain, you would be dealing with all of these issues. And you would be basically programming reasoning explicitly through your prompts, through the programming order, everything you would be doing. That would make your entire application a little more less flexible and more brittle. Okay. So as a developers, we were spending a lot of time writing these custom connections to external system, writing these custom code for parsing the output, writing custom code for managing the different function call formats that different models are producing, or even making custom logic for reasoning. Okay, that's a lot of work that was being done when we didn't have reasoning models and MCP in the picture. Okay, so let's take it with an example. Let's say we want to build an agent that helps users plan the weather conditions. So, for example, we want to know if I'm stepping out, do I need to take a raincoat or not? Okay, or do I should I wear something which is a little more comfortable for the heat that is outside there? So, let's suppose we want to make an application that helps you to plan this case. So, for this, what we would first require to get the user's location. Then once we have the location, we would want to get the weather forecast for that location. And then once we have that, then we can use an LLM to recommend, what should be the clothing suitable for this forecast. Okay. Now to build such a simple agent, we call it React agent because we are first reasoning in terms of, what should be done, which we predefined that, okay, first get the user's location, then get the user forecast. That's the reasoning part. And then we are acting by providing the recommendation. Okay. Now, in this case, we would need to define and implement a custom location and a weather tool to get the location and the weather details for the user. Then we would need to craft a custom prompt for this explicit reasoning that, okay, whenever the user is asking this, first get the user location using this tool, then get the weather forecast using this tool, and then provide the recommendation based on these two information. Okay. You would also need to write a custom output parser. Every time you make a call to the LLM, you need to extract these key details from the models, like what was the tool chosen, how to call that, etc. And now, if you change the model, you would have to do that again, or you would have to write different custom output parsers for different models. Okay. Once you have done that, you need to write the explicit reasoning loop where you will define that, okay, first this step will be called, then this, then this. This explicit loop, this reasoning loop would have to be written explicitly in program, right? And then you would also have to design and program fallbacks and error handling for each of the steps where you are not able to get the user location, probably because user denied that, or whether you are not able to get the forecast because you don't have the user information, or you don't have or the access to the weather server is not available. So there are all the scenarios that will handle, and you will have to write fallbacks and error handling for each of these scenarios. Now, building such a simple application with just LLM and non-reasoning models and MCP is very complicated, and you can imagine, like, at any step you can make a mistake and the application might break in production. Okay. Also, one more thing, right? As I was mentioning about stateless transactions, where you send in a prompt that, okay, hey, give me the recommendation for this user. This is the location, this is the forecast. Give me the recommendations. You get a response. You pass that to the user. Now, user says, hey, but I don't like it too warm. So then the chain in itself, or the loop in itself, has to be designed in a way that whenever the user gives a response, you store that in the memory. And whenever the next response or next request is sent to the language model, you send along with the user information and the weather forecast, also the response from the previous interaction, and then go again. So all of this to handle the stateless nature of the model, you would have to define it in your code. Okay. So the current approach of manually tracking the context, explicitly defining the memory where it should be stored and how you want to pass it, and separate context for each of the tools is something that we have to take today. But the ideal approach would be that we have a unified context. Everything that we pass or everything that we share with the model is stored somewhere in a state already for us. We don't have to manage the state for the interaction to the external tools. We don't have to track the conversational flow. That is something that reasoning models can handle automatically for you. You don't have to handle the state, like whatever the response was given and anything. The MCP can handle for you. That's the ideal state we want, and that's where we bring these two core concepts of AI reasoning models and the MCP into picture. Okay, so the future of AI, which is already here, it's not future actually. We are already building systems using AI reasoning models and MCP. Is with these two stuff. Okay, not just line chain, not just any LLM model. You need to use reasoning models. You need to use MCP to make these even simple sounding applications work in a scalable manner and a flexible manner. Okay, so let's just talk about how these advanced reasoning models and MCP work together to make this a reality. Okay, so newer generation models or the large language models that you might see after GPT-4, there is a different model that exists. Like we have GPT 3.5, 3.5 Turbo. These used to exist. They still do. Then we have GPT 4, 4 model, 4 Mini, and then OpenAI launched 4.0 Mini model. O stands for the reasoning models. And similarly, in the Anthropic side also, we have Sonnet and Opus. These models, they are also now reasoning models. So if you go for the latest models that exist, they all are reasoning models and they have built-in agentic capabilities. Okay. Previously, as we were manually orchestrating these chains, with these new models, they have the reasoning capabilities, so they can think. That okay, give these models the tools. And don't tell them that you need to get the user location first or you need to get the weather forecast and then recommend. You don't have to program it now. Now you just have to give these models and instructions that hey, you can use this tool to get the user location. You can use this tool to get the forecast. And whenever user is asking you about that what should I go where outside, you can use these tools and give the recommendation. Okay, this is just something that you would have to define in the prompt. Now the reasoning model can itself decide, okay, I need to first get the user location to get the forecast based on which I can recommend. So let me first call the tool which will get the user location. Now once I have the user location, I would want to get the forecast for the user. So let's just do that. And then once I have the forecast, now I can recommend to the user. So all of this reasoning, the model is going to handle it on its own. You don't have to manually orchestrate it. Next, previously, since we were defining the orchestration, we were also defining that for step one, use tool one. For step two, use tool two. Everything was, the tool selection logic was also defined or hard coded in a manner. Now, model can derive at the runtime based on whatever the input that user has given, whether I even need to use a tool or not. If I need to do, what all tools I need to use, what all tool parameters I need to pass in to make the call, and what order the tool should be called in. Everything these reasoning models can decide on their own. You don't have to make that decision in advance. That makes your application a lot more flexible because now anytime the scenario changes or anytime you wanna do anything differently, you don't have to redesign your application. You just have to redefine how the reasoning is happening through the prompt itself. Okay, so previously what was a rigid predefined flow is now very flexible and adaptable interaction with the model. Okay, so I think I clicked on it. Just give me a second. Just give me a second. I accidentally clicked on it. Okay, now let's move on. So these built-in models, sorry, these reasoning models have built-in agentic reasoning. So for example, they will think aloud of what are the capabilities they have. Then they will do step-by-step reasoning. Okay, to do this task, I need to do this. To do this, I need to do this. All of that reasoning will happen behind the scenes. You won't even see it, but you can see it if you want to through the model logs. And some models do allow you to see token by token everything. That's costly to do, obviously, but just for your curiosity, you can see what are the step-by-step reasoning that the model is making. Model will understand when and how to use the tools, which tool to use, when to use, when not to use, sort of. And then this process in itself reduces the hallucination because now the model is able to decide on its own based on the input that, to get this information, I should use a tool. If I don't have it, then I can just, say that I don't have access to this information, sort of. Okay. And it also enables multi-turn tool interaction, which means we can build sophisticated reasoning, like I was mentioning that, to answer this, we should get the user information, we should then get the user forecast, etc. All of that sophisticated reasoning can be handled by the model in itself. Which eliminates your manual orchestration loops, which was required previously with just using LangChain without the reasoning models. Okay. this in itself, like, I mean, just recommending the user what outfit he should wear based on the weather is very basic. But think more complex scenarios that also this reasoning models can handle. So, they can think critically in terms of how to solve a problem, and then, given the access to the tools, they can start solutions as well, and even making the calls to the external tools to actually solve the problem. Okay. Then, as I was mentioning, these tools or these models, sorry, actually adapt dynamically based on the responses that the tool is giving. So, for example, a tool is not able to answer or give you the information, then the model can adapt. Okay, hey, I wanted the forecast, but I didn't get it from the forecast server. So probably I should just respond to the user that the forecast is not available. So based on this, I cannot recommend right now. The model in itself can reason that, okay, if the tool is not available, this is critical for my information, I should not respond. Previously, you would have to hard code this error handling in your code itself. Now, model is able to handle that. Okay. You can even stream responses from the tool as the tool returns. So, for example, some tool is returning you word by word information, or like, then the model can also process it and show that to the user. Then this in itself make the interaction with the model very natural and very seamless sort of. Then again, we were mentioning, right, about the memory, that LangChain as a framework has to maintain these memory in itself and then pass on to the context every time. Uh, what has changed with these reasoning models is now the context window has expanded so much that you can pass in the entire conversation history in each of the interactions. Okay, so the model, even the reasoning models are stateless, but the context window, which is to say like what is the input range or how much input you can pass, has become so huge that you can pass in the previous conversation history along with the new inputs from the user as well in every interaction. Okay, so you don't have to manually manage the history, interaction history for the interactions now. Okay. Yeah, for more complex scenarios, obviously you would be doing it if the interaction is getting like really long and even going beyond the context windows. In that case, yes, you still need frameworks to handle it, but in most of the simpler cases, you don't need to handle it yourself. Model can be fed in longer conversation history as well. Okay, so every time you feed in the previous interaction, model now has the full context to answer based on the previous interactions and the current input, and it can answer you right way. As a framework, as an application, you would have to always manage it. You just pass it along, to the model. So this includes tool history, conversation history, everything. They can be coexisting in this unified context that can be passed into the model, okay, in each of the interactions, which enables, very natural multi-turn interaction. So multi-turn interaction means, that I'm making an interaction with an agent. I ask it something, it gives me response back, and then I just ask it again. That okay, given your response now, this is my follow-up question. Okay, so now the model should know, okay, this was asked previously, this was the answer, and this is the follow-up question, or give it back. So, okay. So that's all of the stuff that we were talking about, the which the LangChain lagged, which was interaction with the, how interaction with different systems because the models are producing different outputs, or the maintaining the conversation history, or, reasoning step, which was previously explicitly programmed, is now, something that model can handle in itself. But one thing that the reasoning models cannot do alone is how do you interact with external systems. Okay, for there you need to give the models access to tools, but you could just write functions to interact with external systems, but that way you have to write function for each of the systems in each of your applications, right? Which makes the whole point in an n cross n scenario where you have, like, suppose five different agents to interact with to n different systems. You would have to make one-on-one interactions from one agent to every MCP server defined, and then another, and then another. So that becomes a problem where you are having n cross n number of connections. What with MCP, you define the how do you interact with MCP server 1 or MCP server 2 just once, and then each of the agents can just reuse that definition to interact with the systems. So now anytime if you have to add one more agent, you don't have to, add one more connection. You just have to, connect to the MCP server to get the details. That's the only correction you need to make. Otherwise, you don't have to make, uh, integration with each of the other endpoints. You just have to make it once to the MCP server from the agent, and that's all. So MCP, which stands for Model Context Protocol, is an open protocol which essentially standardizes how agent or the agentic applications interact with the existing applications that we have or existing servers or everything that we have, and how we can provide context to the LLMs from these systems. Okay, that's what the entire MCP protocol is for. Okay, it's only for, how my agent or my reasoning model based agent can interact with external systems. Okay, and again, just like USB-C standardized, how devices connect with each other. So now today we have iPhone having USB-C. So if I want to connect to a headphone, I can just connect it using my USB-C headset. Or if I want to connect to, let's suppose uh, a pen drive or a hard disk, I can just connect to it, or an external camera, I can just connect to it. USB-C analogy makes sense because now any other system that needs to connect to my phone just need to implement the USB-C protocol in terms of programming. Just need to have that USB-C port, and then it can connect to my device. That's it, right? I don't have to, make a different port or different version of my device for different mobile devices. Previously, when iPhone was using Lightning port, and Android versions were using USB-C ports. Every pen drive manufacturer, let's suppose, had to make two versions. One which can connect to iPhone, one which can connect to your Android phone. But now they just have to make one version and it can connect to both of them. That's what standardization does, and that's what MCP will do in terms of how AI models interact with external sources and data systems. So NCP essentially is bridging the gap that these advanced AI models have to interact with the external real world systems. Okay, it standardizes how the applications and tool communicates with the LLMs, so it goes both ways. And this universal protocol for AI interactions with the external tools and data services is changing how we everyday use these AI agents, as well as how even we build AI engines. So before MCP, if you were to build an LLM based application which interacted with my Slack, which interacted with my Google Drive, which interacted with my GitHub account, I would have to make the interactions defined for each of them. I would have to know, okay, what are the API calls for Slack, what are the API calls for Google Drive, what are the API calls for GitHub, and then make a wrapper on top of it, which is the tool wrapper, and then pass it along to the model. That's how much amount of work we used to do. But now with MCP, Slack provides its own MCP, Google Drive provides its own, GitHub provides its own MCP. Okay. Now I just need to know how do I interact with an MCP server. Be it Slack MCP, be it Google MCP, be it GitHub MCP, I don't care. I just need to know how do I interact with an MCP server, and that will handle interaction with external different systems. Okay. So since now both of them are talking same language, uh, which is the MCP, we can easily make connections to different systems. Previously, each of these systems were using their own languages. Let's suppose Slack was, providing its own APIs, Google Drive was providing its own APIs. You would have to custom define, an interaction to each of these systems. Now we just it's like all of these systems are speaking the same English language, and I just need to use that language. Previously, they were using their own alien languages, and I need to, have a translator to translate to that particular language. Now with MCP, I am able to communicate with these systems using the same code, using the same interaction. Okay, so I don't have to custom write every other interactions. Now I can just use okay, I just need to know how do I make a call to an MCP server, and then just pass in, okay, what MCP server I want to call. That's it. That's the only stuff I need to make. So we'll dive deep. How do we connect a Claude, for example, to an MCP server, and how do we make our own MCP server as well? That will give you a little more picture around this. So, what this has changed for the AI agent creation. Like now, when we make an AI agent, we don't we it's not like we stop using LangChain now. This works alongside existing LangChain components. MCP does not, it's not like you have to start learning another framework to use MCP. LangChain also has components to interact with MCP servers now. And if, let's suppose, you have already have a LangChain based application in production, you don't have to stop using the previous tools that you have set up or previous tool interaction that you have set up. You don't have to do that right now. Maybe over the period of time, yes, you can also transfer them to the MCP based interactions. But yes, today, if you want to use MCP, you don't have to, stop anything. You just have to start using it, which enables a gradual migration. Okay, we don't have to rewrite anything now. We can just keep the existing applications in production and add the HCP capabilities, or like, let's suppose my application today is already interacting with Slack, Google Drive, and GitHub, but I previously built my own custom interactions to it. Now I want to interact with the Discord server as well. So now I know that today MCP is available, so I'll start using Git Discord MCP rather than creating another integration endpoint. Uh, and I don't have to right away move previous interactions that I have integrations that I have built to MCP. But yes, gradually I can do that. This preserves the whatever investment has been made today in building your LangChain based applications. It doesn't mean that you have to rewrite anything. Okay. So introduction of this MCP protocol does not mean you would have to break anything in your production. You can just start using it and gradually migrate your previous integration endpoints to MCP servers as well. Okay. Now, going forward, when you will be using MCP servers to interact with external systems, you now have a standardized way to how the tool call should be made. Okay. So now all of the LLM providers can make their own function call. MCP server will be able to handle, okay, regardless of which model is making the tool call output. MCP servers through the MCP protocol will be able to handle that. You don't have to worry about switching a model and breaking the system. You can switch your models. MCP will handle whatever model you are using, however it is producing the output. MCP server will take in that and use it for the interaction. Okay, so you don't have to write now custom handlers for each of the LLM. You can just let MCP servers and MCP protocol in itself handle that for you. Okay. This gives you more consistent behavior, because all the error handling that we were talking about, that whether the tool is available or not, or whether, how do I interact with external tool systems, etc. And if anything fails, what happens is being handled by MCP server itself. You don't have to do it at your end. Now, no matter how many number of agents you are defining or you are building, you can just start using them as is. You don't have to, make your own error handling cases now. Okay. Uh, okay. So let's take this again with an example. Okay. So let's take this with an example. Again, same weather situation. What should I wear for my run today? Previously, you would have to, you would have to write all of this yourself, that okay, whenever such question is asked, you first analyze the user query, identify if the location is missing. If, let's suppose, user has given the location, then use that. If not, then identify the user location by making a tool call to the location service, then make a tool call to the to get the weather location for that for that location, store that in memory, and then make third LLM call to combine the LLM location, weather, and everything, and then generate a recommendation. This is something that you would have to define manually previously, all of these steps and storing the context, everything. Through the LangChain framework, you were able to do it, but you would have to do it, you would have to program this reasoning loop yourself. Okay. So now, in this case, we are basically, making multiple LLM calls for the planning. We are doing explicitly management of the state. So the output from the first call, the output from the second call, and storing it and passing it to for the third call. This is something that as a developer you would have to do it. So developer has to manage the memory in the system. Then any tool interactions, right, to make the tool call that for the first step I want to make this tool call, for the second step I want to make this tool call is programmed or like you're explicitly defined in your reasoning loop. Okay, developer has to make sure that the integration is working with each of the tools, and then the order is defined. In that first you need to get the location details, then the weather details, everything. You need to define that order as well. Okay, so in this case, in cases without reasoning models and MCP, developer has to do a lot of work of managing the state, interacting with the external systems, and defining that reasoning loop in itself. Okay. Now with the AI reasoning models and MCP, that has completely shifted. You don't have to do a lot of that stuff. So again, let's walk through the same example. In this case, what should I wear for my run today? Behind the scenes, now the reasoning model will say, okay, user is asking me what should I wear for my run today. In that case, the user location is to be known because that's, I mean, to answer this, and this is the reasoning I'm telling you what the model is doing behind the scene. Okay, you don't see it on the slides, but behind the scene now model will reason, okay, to answer to this question, I need to know what is the weather forecast for that, for the user. Okay, and now to know the weather forecast, I need to know the user location. Now again, user has mentioned time. See, forecast is also not just location, but time is also a variable there. But user has defined that I want to know it for today. So for today, I need to get the weather forecast for the user, and then to answer that, I need to get the location data for the user. Okay. No, in that case, you would be, and once I have that, I can analyze the forecast conditions and I can, provide you the best recommendations or best practices for the run. Okay. So based on this, all of these processing, and mind you, again, to get the location, to get the weather, again, model just use the MCP to interact with these external systems. I don't have to define the custom integrations with my external location services, my external, weather services. I just need to tell model that, hey, these are the MCP servers that are available to you for this information, and model will basically choose when to call, in what order to call, and how to call it, sort of. Okay. Based on all of this, it can generate a response that based on your location, which is Seattle, and the weather is 45 degrees Fahrenheit today, and light rain is expected at 4 p.m. For your run, it's recommended that you take like a moisture wicking layers and light proof, waterproof jacket, etc. Okay. Now all of this is happening seamlessly for you. This integration with external systems, without the developer having to orchestrate what step one and step two have to look like, without the custom tool integrations to be written, without the memory management to be handled by you. All of this is happening because you are using AI reasoning models and MCP behind the scenes. Okay. Again, let's take it with another example, which is, let's suppose my order number is this, which haven't arrived today. What is happening? If refund is needed, give me. That's the question that the user is asking. Okay. Behind the scene, now model would say, okay, to identify this, what is the, to answer to this question, I need to know what is the latest status of the or particular order. Okay, for this, I need to interact with a system that gives me the order status. So I will make this call. Next, the model would know, okay, the status return says delayed. Okay, so model would say, okay, the response from the first tool has come up and it says delayed. So that means based on the order status, I need to decide whether the refund has to be issued or not. If the refund has to be issued, model is making that decision itself. You don't have to define anything. Based if the refund has to be issued, I have another access to an MCP server which can actually issue the refund. Let me call that. And then the order is refund is issued to the user. All of this reasoning, all of this is happening. Orchestration, execution of call is happening behind the scenes with the reasoning models and the MCP. You don't have to do program it anymore. So based on this, the model can respond, hey, I've checked your order and I found it significantly delayed, and based on our policy, we can do an automatic refund, etc. So this autonomous decision making of whether to refund the order to the user based on how long it has been delayed. This multi-turn tool interaction, and generating a response based on the user input rather than defining that okay, this is the this if the user gives this sort of question, then follow this loop. If the user gives this sort of question, then follow this loop. You don't have to do any of that. The model is able to decide based on the input from the user, how do I adapt, and based on the tools that I have available, how do I respond to the user using the tools, how do I reason, and give the answer. Okay. So all of this happens behind the scene. You don't have to worry about it. Whereas if you were not using these AI reasoning models, you would have to define the reasoning loop yourself. That okay, if the user question is about order status check and refund, then follow this loop. That okay, first get the order status, then if the order status is delayed, do this. You would have to program it. Okay, but with reasoning models, you don't have to do it. That shift in terms of the amount of adaptability that these reasoning models brings, the amount of flexibility and scalability that these models, scalability in terms of more use cases you can adapt, right? You don't have to program one more reasoning loop to do it. You just let the model decide on its own. Okay, so all of this is possible because you are using reasoning models today. Okay. Now let's take our hands on in terms of let's look one of the reasoning models in picture and let's look at one of the NCP interaction. Okay, and how do we set up that in our case? Okay, so one of the agents that all of us use today, and it's an agent. Okay, a lot of people think it's just an application. Behind the scene isn't it's an agent in itself, which is known as Claude. Okay, so I'm sure everybody of you, or at least most of you, have used Claude till now. But if not, I highly encourage to use it over any chat GPT or anything, because this in itself does this entire integration, reasoning and everything for you. You can see the reasoning as well. So this just makes things very clear, very visible, and uh, you can just start using it today. All of whatever we are talking about today. Okay. Now let's actually switch the screens. I'll walk you through setting up an MCP with the Claude. I'll walk you through, how do you use that? How do you work with that? And we'll look at a couple of MCP servers in this demo. Okay. So I hope my screen is visible and clear. Okay, so this is your Claude desktop application. Again, to do this MCP integration or like interactions, you need to use the desktop Claude application only. It does not work with the Claude web app because the MCP servers that we are going to use today, they are locally running on my system, so they don't work with your. You cannot you can set up or connect to the MCP servers on the web application. You need to have the desktop application running. Okay, so if you click on the plus icon here, if you go to the connectors, you can see this thing, right? I have few of the MCPs already set up, which is Gmail, Claude in Chrome, file system, Kite, Supabase, Weather. These are the different MCP servers that I've already set up. Okay, and there are many more that you can do. So if you go to plus connector and if you go to browse connectors, you can see many MCP servers being available. So let's suppose you have the Slack MCP server already available. You have, let's suppose, um, so if you are using like Microsoft 365 or for generating slides or anything, you can use this. You can interact with Canva through this. You can interact. I think these are the one that I use a lot. Then, if you have access, if you were to basically deploy or manage a system on AWS cloud, you can use AWS MCP. Similarly, you have Azure MCP. You have Gmail MCP to get the email information as well. There are many MCP servers, and you can see many of the companies have built their own MCP servers over the period of time. And you just have to connect to those MCP servers to get the details. Otherwise, previously you would have to, define how do you interact with Airtable or how do I interact with like ClipUp. There are so many of this which are available. I mean, it's an endless list. I can just scroll it. It won't even end. There are almost any system that you can think of today has their own MCP server existing, like even Tableau or Power BI. You can do a lot with these servers. Okay, so let's just look at how do we configure one and for our case. So what we want to do is we want to build or configure a Supabase MCP server. Now Supabase is a backend as a service. So let me just quickly open the website. So Supabase is a backend as a service. Let's suppose you are a front-end developer and you don't know or anything you want, you don't anything about how do I build the backend. You don't actually have to do it. You can just directly use the Supabase APIs to store your data in the Supabase database, or let Supabase handle the authentication authorization for you. You don't have to worry about any of this stuff. So this is the supabase.com website, and I have few projects already set up. Let me just delete them. Actually, I don't need it. Okay, so this is the server, and then if you want to set up the MCP for it, what you can do is you go to your Claude, click on the Claude here, click on the settings. Okay, uh, then you go to the developer and you click on edit config. Okay, this opens my file system dialog box, and this is the file that you see Claude desktop underscore config. This file is where you define the MCP server to interact. Okay. Now let's suppose I want to connect to the Supabase server. I just need to add this entry in this file, and that's all it's needed. Again, this is my access token to interact with the Supabase server. So basically for my account, I have created a what do you call a token through which I can interact with my Supabase account. And yeah, I just need to add this that use the Supabase MCP server, and we are using it like npm. This is a npm module, so we are defining that just call this command to run this server behind the scenes. Okay, I'll even show you from the logs how it looks like behind the scenes, so it's not like a mystery box to you. It's no magic. It's all work based on the good programming that has been done in the MCP itself. Okay, so similarly, I have added Supabase. I have also added a custom server, which I'll come back to it. And then you can also add more servers here as you want to interact with it. Once you add the entry there, you just need to restart your Claude desktop application, and then you can have the interaction with it. Okay. So let's start creating a Supabase project, and let's see what happens behind the scene. Okay. So I just switch to the chat mode for my case. So here I'm using, firstly, you can see I'm using Sonnet 4.6 model, and in the effort I've chosen medium. So this effort is how much reasoning effort you want the model to put in. So for simpler tasks, you should choose like low or medium, but for more complex tasks, you should use high or max. And based on what reasoning effort you choose, the model will be consuming more tokens. So yes, choose wisely. Okay, and then we have more complex models as well, which is Opus and Fable. We should be used based on, the complexity of the task, not just anytime you want to use. So I just say, hey, I want to make a simple to-do application. Help me set up the backend for it in Subakis. Okay. So it might ask a bunch of questions to me, what should be the project name, what should be the location and etc. But see, even before that, you can see that it is thinking, reasoning about, okay, to make such an application setup, I need to set up a project in Supabase. So for this, it basically, just it basically listed what are the Supabase MCP tools that are available. So based on that, it loaded 5 Supabase tools that are available to it. These tools are again defined in the Supabase MCP server, which I just showed you how we connected to it. So one is the create branch tool, another is confirm cost tool, another is create project tool, another is list project tool. So all of these are available. Okay, so this is something that this is the kind of call that was made to the Supabase MCP server that, okay, I want to create a development development project on it. What do I make a call? So I will also show it in the logs what happened behind the scene, but let's just first make the call. So firstly, we are listing the projects based on the available tools. We are just seeing if we have an existing project to use or not. So let's see the response. Okay, let me also open the the log side by side, so I can show it to you. Just again going to the developer, we can see just go to Superbase and we click on logs, we can see the logs uh, as well for us. Sorry, accidentally. Okay, I'll go through the logs after this. Let's just see it in action first. Okay. Okay, so I just say yes, use Superbase for it. So okay, let me actually probably my token expired, so let me. It's a good thing to do. So I need to update the token. Let's just do that. Let's go to edit config. Uh, let us get the new token. So just go to accounts, click on account, access tokens. Okay, yeah. See, it's expired. That's why it was not working. Let's generate a new token. Superbase MCP set expired in 30 days. Generate token. Okay, let us copy this token. Only one time you can copy it. Let's go back here, save this, place the token, save it, close it. Let's just close the Claude app itself also and then restart it. Because we need to restart the MCP server, which only happens when the Claude app is restarted. So let's restart it once more. Just give it a moment. It's taking a little time for my Claude to load. Okay, ready. Okay, let's go back to the same chat. Just ask it to try now. So behind the scenes, since this is using reasoning models, so it is able to handle the context well, reason what are the steps that are needed. So it in itself identified and okay, supervisor is connected. Okay. Create a simple first aid. Oh, right, select it. Just um, just changing the model to use. Sonnet 5 medium. Okay. So using the cost tool, it came up and say, hey, this is free. So in itself, the model in itself recognized, okay, to create a project, let me first get the cost and show it to the user, right? I didn't ask it to show me the cost. In itself, the reasoning model in itself decided that, okay, to do this, I should first get the cost and share with the user, like what will be the cost of creating the project and using the cost tool, right? Let's so firstly it listed organization, which is as a part of Superbase, like we create organization and based on that you get it. So it got the organization ID. Now based on the organization ID, it made a call that okay, this is the organization ID. What is the cost for it? And then you get the cost, which is zero amount. Based on that, it says it is costing zero. So let us start creating the project. For this, it says okay, I have the cost ID confirmed. So let's just make the project, which is the name simple to do in this organization, in this region, AP South 1. And then based on that, it got a response that, okay, project is now up and running. So then this says, okay, the project is live and now we can set up the tables as well. We can also, it in itself ran few security checks as well on this for the row level securities. And then it gave, okay, that the project is created and you can start using it. Okay. So if we go to the Superbase, we can see the project ready for us to use. So we see one more project, right? Initially, we started with 4 projects. You see this new simple to do app project, which you can see the same name. Created in AP South 1, created in AP South 1. Now it's ready for us. So, okay. So model, reasoning model in itself decided that, okay, to create a Superbase project, let me first get the cost. Based on the cost, show it to the user. Then if since else, if the cost would have been something, $100 or something, it would have asked me that, okay, this is costing $100. Would you want to make a request or not? Then I would have, based on my response, it would have taken the next step. But since the cost was zero, in itself decided that, okay, yeah, since the cost is zero, let's just start creating the project. Then it made another MCP tool call to make the project, and then got the response. Based on that, it says, okay, the project is now ready to use. All of that happened with the reasoning models and the MCP together. Okay. In itself, it decided that, okay, I should also enable row level security for any public level, public read, insert, update, delete policies. So, we can immediately start building without the authentication. No security warnings will come up in this case. Okay. So, all of this decision is happening behind the scenes using the reasoning models, and the actual function calls to the Supabase server is happening via the MCP. Again, I can also show you through the logs here, whatever call has happened and stuff. So, for example, um, right. So these are the MCP calls. Like, don't get too confused about them, but it's just to show that, okay, first it made a method called to list the tools. Okay, then it made a then it let me also show the another call to create the project. So it is making the tool calls. Just identify. Actually, okay. Yeah. So you can see it is initializing the MCP server and using the MCP server command to connect to it. Then here you can see the actual call as well. Let's look at, find out the call to the so you can see the server interactions here with the MCP server being initialized, and then server responding with, okay, these are the things that I can do along with the tools, details, etc. Then I make a call to list the tools. Then it says that, okay, I have search dogs and more tools. It's truncating the information, but it will share all of the tool details from the MCP server has. Then you can moreover also see the actual call. I'm just trying to find out the actual call. Should be at the last. To create the project. Okay. Yeah, I think this has not loaded. Let me load it again. Probably the logs are not refreshed. So developer, copy this logs. These, going through these logs helps you understand what is happening behind the scenes, and every call to MCP server, what output comes in, uh, how like first it is listing all of the tools that are available, then making the actual tool call. So yeah, there is the tool call to make the cost confirm. Okay, so it's making the tool call to get the cost. Then you get the response that amount is zero. Okay, then there will also be tool call for the another method, which is the project creation. I think so this is there, like create project tool call. You see, to the tool call has been made to create the project here, passing in these arguments, and then from message from the server is that, okay, this is the project ID, this is the project name, and it is now live. Okay, this is the exact same thing that we saw in the Claude app as well. So this is how MCP interactions happen when you are using, an agent which can connect to the MCP server, and you are using a reasoning model which can reason on its own that what are the steps to be done to actually create this sort of project. Okay. Now let me show you one more example where we talk about a custom MCP server. Okay, so I have, as I was showing you previously, that in that file, in that list of files where we were adding the MCP servers, I also have added one more server which is like a Python file, which is my own MCP server that we have created. So here you can see in this, look at this one weather. So you can let me zoom in a bit. Okay, so here you can see the command that, call a Python 3 command, and this is the file argument we are passing, which is the file path where we have the MCP server. So what it will do, it will start the MCP server when the Claude app starts. That's the only thing that this config does. Yeah, we zoom out a bit. Okay, enlarge it. And this is one of the MCP servers that we have created. Let's actually first see it in action, how this MCP server works, and then we will walk through the code and look at, the logs as well to understand a bit more about the MCP server. So this MCP server is there to tell you the details about the weather, and as you can go to the connectors, you can see the weather MCP server available, and this is my custom MCP server which I have built. Okay, so again, weather information is something which this model can already provide. It has internal tools as well, which it doesn't list here, but it has access to those tools. But I have to specifically say that, okay, use my MCP server to get the weather details. So what is the weather in Delhi right now using the weather MCP server? Okay, so I have to explicitly say it because otherwise it would have just used its own tools and stuff to get the weather details, because weather is like very common thing that this Claude can already do. Okay, so let's see if it. Okay, I don't think it did use the MCP server. It got the weather data from Google. Okay, so use the MCP server connected. Not okay. So yes, it has found the tools. I have the weather tool available. So see, it has found the tool that, okay, I have the weather NCP server available, and within that weather NCP server, I have one tool which can get me the weather details. I need to pass in the latitude and the longitude. Okay, this is the tool details for that MCP server, and each of the MCP server has certain number of tools. This MCP server has the tool. Okay, and then this is just the description of the tool and what are the properties for the tool call, what is the name of the method, parameters to pass in and stuff. Okay. Then if you click on the next get weather, this is the exact call that is made to the MCP server. Now you see the request being passed in with the latitude and the longitude, which it got in itself. I didn't have to provide it the information. And then it got the response from my MCP server. Okay. As we will see in the MCP server code also, you will see this will resonate well. Based on this, it has produced a response in a formatted way. Okay, I didn't ask it to format it. It itself decided, okay, this is something that the user would want. So the reasoning models along with MCP server gives you this flexibility that you can just ask it in a simple prompt. Reasoning model in itself decide what MCP server to call, what are the parameters to pass it to it, then make the MCP tool call via the MCP server and get the result for you. Okay, let's jump back and see it in code as well. So this is the MCP server. We just said any MCP server you can build it using the fast MCP, which is another library to create your own MCP servers, and rest all of these imports are standards. Then this is the API endpoint which you are going to use. Now this API endpoint is unauthenticated. We don't have to pass in any tokens to get the weather details. So we are using this. Okay, now as we showed there, right, that we created one MCP tool. This is that MCP tool. Look at the parameters and the function name. So function name is get weather. The parameters are latitude and longitude. Both of them are float. And then there is this description for the tool that get weather for a location, arguments, latitude, longitude, etc. Right? This is the exact thing that we see in here. Okay, get weather for a location, the sort of the name of the method in the weather class, get weather in the weather MCP server, get weather is the name of the tool, and then these are the parameters. This is the exact detail. So what happens behind the scene? when this agent is interacting with the MCP server, what it does, it basically starts an MCP client to connect to the MCP server. Using that MCP client, it connects to MCP server, ask it to share the details, like list what are the tools available, what are the definitions of each of the tools that you get it, and then it can make a tool call passing in the right parameters. Let's again see it in the logs to just confirm whatever I'm saying is not made up fact. You can go in the log, you can go in the weather, you can go in view logs. You will see the exact same thing that I was mentioning, that it first started the MCP server, like the server.py file that I have. Then it would basically, let's just scroll a bit. Okay, there is some handshake happening, initialization and everything happening. Then look at the tool list. Okay, so this is the tool list method that it called. Okay, and based on that, the server responded that okay, this is the tool name, this is the description, this is the arguments, etc. Okay, now the model knows what is the tool name, what is the argument to pass in what format. Now model make another, or the agent makes another call via the, like, based on the output produced by the model. It makes another call to call the weather, get weather data, passing these two arguments. And then the MCP server is behind the scene making, making a HTTP request to Open Meteor server to get the weather details. And then it responded with the details which are truncated here. So it's sharing in for this latitude, longitude, these are this, it's truncated, but it will share you the server is responding with the data. And based on that, the further interactions are happening. Again, we can just confirm it from the code as well. So in the code also, we can see we are just making an API, a URL to make the weather request. So calling the Open Meteor API base / forecast, passing in the latitude, longitude, and a few of the parameters. We make a call, which is happening in this make OpenAI Meteor request call. We are passing in, building a header, and then making a HTTP call, creating HTTP client, making HTTP call, waiting for the result, etc. And then if no data would have been written, this is something that would have been returned to the client. But since the data is returned, the JSON dump which is returned from the API is returned to the client, as we have seen in logs as well as in this get weather tool of this here as well. Okay, so this is what has been returned from the MCP server, and we can see, right, it's a result.json dump, and that is exactly, you see, result.json dump. Okay, so building these MCP servers, MCP client, and building an agent using MCP is no magic, but you need to understand the basic fundamentals, right? So all of this MCP server is not. I started this session saying that tomorrow there is something. Today we are talking about MCP. Tomorrow there is going to be some other protocol, and these things keep evolving. But if you know that behind the scene you would have to make an API call to get the data, and you would have to set that up as a server to do that call. If you understand these fundamentals, then only you can build on top of MCP and all, which I believe all of us here already have that, since we all have been in industry for quite a while. We have good fundamental knowledge. Now, that knowledge today, if you don't build on top of that knowledge using whatever latest in the market, you don't upgrade yourself, you won't be able to catch up to what happens tomorrow. Okay, so our industry is like such that every time we have to keep learning and upgrading ourselves as well, and this is what we are trying to do through this courses as well. So this is again this is how your MCP server is custom built and defined and can be used as well. Okay. Let me go back to the slides. We'll talk about the last leg of this session, which is about how do we navigate this transition. Before that, I would like to check with Niyati. Do you want to have some minutes to talk about anything, or can I continue
No,
and talk?
you can continue, Pratik. I think we can end the session. I'll just then launch the last poll.
Okay, perfect. Thank you so much. So all of these slides, I think, I was also shared with the learners, which has which has all the details, and then we have link to the MCP server, etc. But you can build on your own as well once you understand and learn about these concepts better. Now let's quickly look at how do we navigate this transition? How do we move, from being where we are today to being AI ready? And actually not, sorry. You AI ready is also a thing of past. Now you need to be AI first. Okay, everything that you build, everything that you learn has to be done in the thinking that how can it be done using AI. So I'll give you an example. So I was working on something recently, and I had to uh, send in a task to the team, and I need to I basically had to send in bunch of tasks to the team in a chat group, and I have to ask them, okay, just update on this thread whenever you are done. Now previous me would have been, checking the thread continuously, making a note somewhere in my notes or Excel, tracking the items manually for me and all of that stuff, right? That's what we typically do. But I didn't do that now because I am thinking AI first. I thought, okay, how I can do this with AI. So what I did is I connected my Cloud desktop application on my work machine to my Slack NCP to the Slack server, the NCP server, and basically connected. We are using Slack for that communication. So I just used the Slack MCP server and just what I did is pulled in the Slack thread ID and shared to my Claude and asked it, hey, this is what I asked in the thread people to do. Can you summarize who have done it and what are the pending action items? It did that summarization and then asked me if I want to draft a message and send a message of the pending items. And I did that, yes, draft and send, and it drafted a message and send it from the Cloud code itself. I never had to even open the Slack, understand what is going on in the thread, everything, because it's a very tedious, very basic thing, right? Model can easily understand and do it. So I did that, and using the power of reasoning models and MCP servers, even my everyday, day-to-day sort of work life is changing because I am thinking AI first, and that's what we also need to do now. So that's the key thing in terms of the transition we need to think about. Okay. Um, so previously, if you were like focusing just on line chain and having agents, chains, memory system, output parser and stuff, uh, sorry, now you would have to start thinking about how do I, build using new models built which have built-in reasoning capabilities. How do I change the interactions with the external systems with the MCP? This is the first shift that you need to make. Okay, so if you are making, if you are making land graphs or land chains with, orchestrating sequence of steps and operations, everything where developer has to explicitly define what steps to make, what tools to call, when to call, etc. You need to switch that with using models which can handle the multi-step reasoning internally, which can interact with external systems through MCP. Okay. Traditionally, if we were building reasoning loops ourselves using like React patterns and all, using different patterns that we may have heard about till now, you have to let the model now do the reasoning in itself. You can now let the model decide on its own which tool to use, when to use, and then using MCP to for the tool interactions. Previously, where you were doing the memory management through conversational buffers and summaries, etc. Today, since the models have a large context window, you don't have to do that memory management on your own. You can just pass in the entire conversation history every time, and the model would be able to handle it itself. Previously, where you would have to write the custom parsers to extract the structured data from the models and build like complex regex and JSON formatting rules to make sure the output is parsable. Today, you don't have to do it. All of these reasoning models have native JSON modes, and they are custom. They have been designed in a way that now JSON outputs they produce won't be, breaking, or they would adhere to the format of the schema that you have defined. It has become a lot of reliable with these newer models. Okay. Um, so if you were to give an example, if you were to build a customer support ticket resolution system, where we would have to define a router chain to route to the document retrieval or the order status chain or the account information chain, and then write another chain or React to do the solution generation, action creation, everything, and then have a memory chain to manage all of that stuff. So this sort of system, if you were to do it in a traditional manner, you would have to write more than you would have to write more than 7 custom components, a lot of line of codes, and huge complex integration. But with this new AI reasoning models and MCP implementation, all of the interactions with the external tools goes behind the MCP servers that you have. You don't have to make one, per tool interaction or integration anymore. And with the way that we even demonstrated right now that we were using Claude, desktop app to do the reasoning and MCP tool calls, we can just do that and let the reasoning models handle the interactions. So now we have less tool interfaces to define. We just have to define one MCP server. We have less code to write. And obviously, if we have less code to write, then that means that it is much more maintainable. And having built-in reasoning means you don't have to define explicit reasoning loops as well, which are brittle and which are not flexible as well. So the new AI development stack involves using reasoning models, involves using MCP for the tool interactions. So our focus as a developer need to shift from creating just the tools to from defining explicit reasoning loops to just start using MCP tools and creating agents which leverage these MCP and the reasoning models. Okay. So how do we prepare for this transition? Short term, we first need to define or identify which components in a system needs to be evolved and needs to be replaced, or which can be stay as in for now, but they can be replaced going forward with MCP servers. Then we need to begin converting our critical tools that we already have to the MCP compatible services. We need to start implementing, experimenting with Claude's tool capabilities and all of these reasoning models tool capabilities a bit more. We need to simplify our complex reasoning loops by leveraging models inbuilt reasoning rather than our defining our own reasoning loops or custom loops. Okay. This has to be like a multi-step. All of that multi-step prompt reasoning happens inbuilt behind the models. You don't have to anymore, write your complex workflows. In the long term, you need to invest in defining high quality MCP servers. You need to build your expertise in how do I build good MCP servers. MCP servers are not just tools, as you would learn in this program as well. That MCP servers are have prompts, resources. There's a bunch of stuff that goes behind how do I build an MCP server as well. We need to focus on data quality also because now that we have democratized how we interact with the tools, it is very critical that the next focus that comes in is if the tool is holding the data of good quality or not, or let's suppose if you are using MCP server to interact with your SQL database, but in your SQL database the data quality is very poor, then in itself the responses would not be good. So now the once the MCP server and these things you catch up to, now the next focus would be on having a good quality data in your backend systems. Okay, so a quick walkthrough of how do we prepare for interview as well. So we would probably have like medium to hard questions on the interview based on these topics. So let's just look at what these questions are and what would be the answers. So what are some of the concrete limitations of current LangChain mechanisms? This is a very common questions that get asked. Like if if LangChain is so popular, then what is the problem with it, or why do we not just use LangChain to build our applications? To answer such questions, you need to think critically in the sense that you need to start thinking, okay, is the LangChain framework that exists today, is it scalable? It's not, because every tool call that we need to make, or every call, we need to define what is the orchestration loop, what is the reasoning loop, what are the function call formats that each of the different models would require. So it's not very scalable and flexible in that manner, and the integration with external systems require you to handle unexpected outputs, and there is no standardized error recovery that is happening behind the scenes. Then how do that these LangChain frameworks, they are not managing the states on yourself. You will have to write custom code to manage the state. And this all in all results in an impact where developer is spending more time in writing these custom connections and handlings and everything rather than focusing on the actual business logic and providing business results. Okay. So, whenever you are answering such questions in an interview, you need to think what do you know about the current system and what do you know about its limitation in terms of, what exists, or what are the challenges, actually, not just limitation, what are the challenges using these systems and what is the actual impact of those challenges. Again, if somebody may ask, like, what is the LangChain agent versus Claude plus MCP do for you? When do you still pick LangChain? So obviously we were mentioning, right, LangChain needs an explicit React loop for you to write, whereas Claude plus MCP, as we just saw, does that multi-turn tool reasoning natively in one call. We don't have to do anything. Again, LangChain, you would have to manage the state via the conversation buffer memory, whereas for MCP, it's keeping its own state. It is maintaining the tool outputs and history in itself. You don't have to manage that yourself. Again, tool integration is difficult with LangChain, whereas MCP is like a standardized way to interact with the tools. That in itself means in terms of impact. See, telling the challenges and all is fine. That tells you the book, whatever the theoretical knowledge you had. But unless you tell what is the actual impact of those challenges, the interviewer would not know that, okay, this is the person who can actually, solve the real problems. Because theoretical knowledge, it's very easy to grasp, but actually applying it and then thinking in the sense of, how it impacts the business is critical. So the final answer should always talk about what is the impact of doing picking one over the other. What is the impact of the trade-off? If I do this, if I do that, there is no right solution or wrong solution. I would not say, okay, now that we have reasoning agents and MCP in picture, we should forget LangChain and LangChain agents. No, in fact, you still can use it. You still should use it, but it depends on the scenario and it depends on the complexity of the problem statement. So knowing the trade-off and choosing the right decision in that trade-off is what defines you from just a developer to actually a solution architect. Okay, I think we are right on time. Niti, we are open for questions now.
Yes. So, while Abhinav, I think, answered most of the questions, I will just screen quickly. There's one question that is still unanswered, which is our multi-step reasoning chain of thought. Do we have any control on chain of thought reasoning or any reasoning?
We do have control over how model think in terms of how much effort the model put in, as we shown, right? In the option when you're picking a model. You do have control in terms of what model that you pick, because that's also decides how much reasoning happens and how reasoning happens. And then lastly, you have controls in terms of how you prompt the model or how do you navigate the model. And one more thing that you have control over the reasoning, in the sense that through the harness. We talked, I don't know, you may have heard about this term harness engineering, which essentially is defining, through the code or through the markdown text or, a lot of stuff, which essentially guiding the model in the sense that how do I, how should the model produce an answer, or, how should the model think? So it's all comes under the umbrella of, choosing the right model, choosing the right effort for the model, defining the right prompt for the model, and then defining the right harness for the model to reason.
Fair. What are the open source alternatives to Claude plus MCP and how scalable are such models? Do you want to talk about some of the newest Chinese models?
Yes. Yeah. So, firstly, we do have alternatives. We do have alternate. So, firstly, MCP in itself is an open source. Okay, so there is no like a closed source alternative to it. MCP is an open source protocol. Yeah, obviously now some of the services they would put a paywall behind that, because see, let's suppose for example Apify is a service which allows you to get the LinkedIn details or some other stuff, right? They do put a paywall, because every time you are making a call via the MCP server, it lands on their server, like backend server, and they are paying a cost for that information. So yes, companies may put some cost in terms of accessing the MCP server and all, but MCP protocol in itself is open source. You can use it anytime. Now, in terms of the model, right, there are different models that exist in the open source world. We do have a Meta's Llama model. We do have latest Chinese models which have come up from Kimi, and it have worked. So worked for a while with them. So Kimi K3 is one of the models which is very popular. It has also come up that okay, this model is sort of beating travel at a front end game. So yeah, this will keep happening. The new alternative models do exist, but then again, they being open source does not mean that you get it for free. Okay, so you still have to deploy them on an infrastructure, which will cost you. So it's just that you choosing a open source model over a cloud model. It's a decision that you make in terms of what model I pick. But ultimately, all of this doesn't come for free. These reasoning models, you cannot run them on your laptop. Like even if you can run them, it will be a very smaller version of a model, which would not produce as good results, which hosted model would do. Okay, so open source versions do exist, but even they would be paid because there is an infrastructure cost which is involved behind the scenes.
Yeah. Unfortunately, no free lunches as of now. The more we are trying to use it for production ready stuff. So yeah, having said that, I have some questions that I want to answer around certificate and recording. Yes, we will share the recording. Obviously, these are live sessions. So once sessions get done today in a couple of hours, the recording is produced. We'll share it when we start the session tomorrow in the morning. We'll share the recording of today's session, and we'll share the recording of tomorrow's session a little later. You can ask the program advisor also. Certificate, yes, if you have attended all of our sessions, you will get a certificate in a few days. There's a question for you, I think, Pratik. How to fix the hallucination made by LLM while extracting RAG to solve the query?
Okay. By the way, where are you? Okay, I see the question in chat. I was checking the Q&A. Okay.
Yeah.
How to fix the hallucination made by LLM while extracting RAG data to solve the query? Okay, there are two questions. So let me first answer the one question. See, hallucination, you saying that model is hallucination or the agent is hallucination is a very broad statement. It may hallucinate for various different reasons. One, and most of the reasons actually come to the context not being available if you are using the latest models. If you feed them the right context, enough level of context, they would be able to give you the right answer. But let's suppose you gave them a very surface level information. For example, you gave the information about the orders, okay, the order being delayed, and this is my latest order status. And now I'm putting LLM on top of it and asking it, hey, what is the latest status of the order, or which are the orders that are getting delayed. The model would be able to do it. It would not hallucinate there, given that you have defined properly what is the table to use, what are the columns to use, what each of those columns mean. If you have provided all of that context, yes, it would not hallucinate. It would give you the right answer. Now, let's suppose given only this information, you ask it why the orders are getting delayed. Okay. Now to answer the why, model needs to know what happened behind the scene. When did the when was the order released, or when was the order shipped, etc. And if your table, if your information does not have that, model would try to give you an answer that okay, delayed probably because of sourcing issue or anything, right? It will just spit out some random answer because you didn't provide the model the right context and enough context to answer the question. So hallucination stemming from a model is not actually a model problem, is more of a context problem that you have not provided the right context. In very few cases, the model may still, given the right context and all, it may still produce the wrong responses or hallucinated responses. That's where your guardrails for input and output comes in, which ensures that okay, if the answer is not right, if the evals are facing for that failing for that output, let me rerun it with more context, etc. That's the whole engineering part that goes behind the scenes to make sure you can work with these models and do the less resulting in a less hallucination responses. Next, in terms of security for the overall applications, there are again multiple aspects to it. One is the user privacy. Then there is user security in terms of, let's suppose you build a chat app where the user can ask the status about their orders. You need to ensure that the application that you build does not get the order details for other users to this user, right? You need to ensure that the information that this particular user is getting is only for them. All of this has to be designed and developed in the application itself. Not something model can do on its own, that you cannot just say that hey, just secure my application. That's not something that would work. You have to engineer it in your application through the code and through the design overall.
Yeah. One interesting question from Krishna in the Q&A section, you'll be able to also see in the interview, do they tend to ask inner workings of transformer models, like inner architecture workings, even for newer models such as Kimi K3?
Okay, firstly, new model, old model, whatever, right? All of these models are working still on the same transformer architecture. What is changing is not the architecture in itself, but how the training is happening, how the post training is happening for each of these models. That's how they are evolving, not in terms of the architecture, but in terms of how the training happens, or what data, then what post training techniques we are applying, etc. Now, the second thing is, in interview, do they ask this? It depends on what role are you applying for. If you are applying for a role such as a data scientist or a machine learning engineer, where you are asked to, fine tune these models or like post train these models, etc. In those sort of roles, yes, you would be asked about, what are the inner workings, and because that's what the core work for you would be. But if you are going for a role which is more like FD role or AI engineer role, or even like a PM in AI space, etc., they would not be worried about what if you understand the feed forward neural networks or not, if you understand how encoders decoders are working in the transformer architecture. But on a high level, it is still expected that you understand what happens behind the scenes. That whenever you're giving an input in English language, it is converted into an encoded vector, which is like numerical, and then goes through this magical model, and then again numbers are spit out, and then they are decoded again in the English language. Okay, so this overall flow, yes, you need to understand so that you don't see this entire thing as a magic black box. But yes, not on the deeper level. It
Hmm.
again, for some roles it might be, for some roles most roles it won't be.
I think Ashok noticed that you had a kite MCP attached while doing so. He's asking, how do you use it?
I did not use it because it basically gets my
Yeah.
stock information and everything. So we can use basically, if you connect kind MCP, what you can do is just ask Claude to get me what are the stocks that I'm holding today, and then through that conversation you can ask, okay, what are the stocks that that you are recommending for me based on my current portfolio. So using that kite, you can, zero the, basically kite stands for zero the there. You can get your current stock portfolio. You can get stock prices of other any stock and do, sort of interaction to get the recommendations around. But again, specifically saying any stock recommendation from any AI model or any of this, you should not take them as is. You should make your wise decision on yourself for, for exercising any final purchases, etc.
Sure. Susan is asking, she is a PM currently, and they are working on a agentic AI project. I think they're asking, is there a technical term for AI agents or prompt tuning training? Yeah.
Okay. So AI agents are not trained as such, they are built. There is no training involved. Training is where the models and all stuff happening. Prompt tuning is not something we do. It's basically we can do fine tuning of the models. Again, you cannot fine tune Claude and all of these models because they are closed model. You don't have access to their weights. But you can fine tune the open weight models, which are like Kimi, Llama, etc. Again, that depends on the use case. I don't. I see a lot of people very eager to fine tune the models, but unless cost is a big problem to you, you should not be fine tuning the models, because to fine tune a model, you need a lot of good data, which most of us don't have today. So yeah, fine tuning is a core part. Yes, it might be becoming more relevant tomorrow, but yet today we should not be focusing a lot on fine tuning.
Sure. I think Abhinav is taking up the last question that Ankur just posted. So we are 7 minutes, over time. I will just let Abhinav answer that. But I think we have taken all the questions in the chat and Q&A again. Thanks to you, Prateek, and you, Abhinav. We will see all of you who are still here tomorrow, and we will continue the topics for tomorrow are going to be multi-agent orchestration, and the fourth one is going to be all about deployment. So obviously, most of the sessions, they do have hands-on at the end, but we have to cover certain concepts so that you understand the hands-on properly. So yes, that brings us to the end of today's sessions. Thanks a lot for joining in, guys. We will go through your feedback also, and see you tomorrow at around at the same time, 12 p.m. Okay, Sanjay, what are the best recommendation to write a RAG for front? Okay, Abhinav is again answering that. Cool. Go ahead, Abhinav. I'm going to keep the session live. Pratik, you can drop off. Thanks a ton for joining.
Thank you.
I'll see
Thank
you
you
soon.
for joining.
Yeah, bye.
Yeah, bye-bye.
Abhinav, I'll end the session once you complete answer.